So the AI infrastructure meetup happening on a Saturday. Thank you all for joining in. We'll try to have great speakers and then good sessions, mostly about the AI infrastructure side of thing, as the meetup suggests itself. Thanks to Cloudera for hosting this particular meetup, and of course, I and Ritik are from vCluster, so that's him, Ritik. So. This particular QR is for our open source project called Wind. I'll tell more about that in a bit. But first, let's try to understand uh, vCluster for building the AI factories. So, what happened over the past few years is that people have been buying GPUs from NVIDIA. So NVIDIA is a manufacturer that creates a lot of infra, crazy infra, and they have like Vera Rubin, which is coming, which will be delivered to their pre-booked customers starting next year first quarter. So they create a lot of hardware. Then comes the vendor. So there are these hyperscalers, AWS, Google, Google, Amazon. These are called the hyperscaler clouds that provide the infrastructure. There are two different terminologies that come. One is the AI factory, one is the neo clouds. So at GTC, Jensen, so I was there at GTC, and in his keynote, he mentioned that tokens are the new commodity. Like every engineer that I speak to, or anyone who's using Claude or Cursor or who's whatsoever it is, people themselves have started measuring in terms of tokens. And that's what the providers are also doing in the same way. So tokens is the new commodity, and your data center becomes the factory. So we are back in the era where everyone is trying to get those GPUs, maybe a single rack for their organizations. And then there is Neo Clouds. What they are doing is they are partnering with NVIDIA to get all the infrastructure, and then they, sell that to the end users or themselves or via the reselling kind of things. So what is an AI factory? If you go by the definition of what Jensen said, the right set of coolings, the right set of hardware in place, so that the GPUs can be utilized to maximum efficiency, the InfiniBand, NVLink, all those things in place so that the GPU sharing becomes easy and GPU partitioning becomes easy, and they are able to serve the traffic. So AI factories mainly like converting the electricity and data into the tokens. Also, the measuring unit for these particular organizations and the neo clouds have become tokens. And you might see that wherever there is announcement from Claude, Codex, or whatever AI platform that is, you will see that per million token and a dollar value attached to that. So even the charging system for these AI factories and neo clouds are token based. So that is why tokens have become very interesting over the past couple of years, I would say. And in between, we have a layer of AI factory. Just think of it as you bought the hardware, like, or there is an enterprise who got the hardware, have one rack, and now they have to give that rack access to their teams. Or if it's a neo cloud, they have to give separate clusters and things to their team. Yeah, so that's what is an AI factory and a AI cloud. So if you see the neo clouds, which are the AI first cloud providers, like for renting the GPUs and selling tokens as a service, you can see some of the names: CoreWeave, Lambda, Crusoe, Nebius. They are the ones, and you'll not see AWS and all the others ones specifically mentioned at neo clouds, although they also give you H100, they also give you A100, they also give you the Blackwell GPU. But the thing is, they are general purpose cloud providers. And general purpose cloud provider means that they are able to give many services across their platforms. Whereas as a AI cloud provider specific to what CoreWeave, Lambda, Crusoe, Nebius, these kind of things, they are buying the hardware and they are trying to create and sell the platform on Kubernetes, or enabling the team to create and build their own AI factories. So there are various reference architectures. If you go to nvidia.com, or if you just search NVIDIA reference architecture, so you'll see a lot like DGX SuperPod is something that is very popular. So you buy these 500,000, 2 million racks, and then place it at your universities and things, and then you will be able to provide that particular AI factory for your need. Um, so that's the current state. So buying the GPU is still something that you have the money and you buy the GPU. But then comes like, how do we actually give this to our developers? Because every GPU sitting idle is very expensive, and you can't just buy from Nvidia and keep the hardware, do nothing with that. So that will become very difficult. So if you see over here, there's a shared GPU state which is having like 4 GPUs. So what a company and an organization means is that they bought from a particular neo cloud or directly from Nvidia. Let's take the example of the Rubin stack. So they bought this whole Rubin stack, the GPUs, and now they want to give it to their customers, or if it's an enterprise, they want to give it to their organizations, different orgs within the company itself. So you can see your teams becomes for the internal teams like team A, team B, team C. And if it is customers, then it becomes, the customer one, customer two, customer three. And in that, we have seen over the past year as well, if you have attended any of the KubeCons, or if you have been reading actively Forbes or some of the articles, that inferencing is the game of 2026 and 2025 as well. So everybody is trying to build the platform or MLOps pipeline or the whole ecosystem around providing these particular chunks of your inferencing engines to the customers. So, but that doesn't mean that only inferencing will be happening. Once you have the GPU, you can do fine tuning, you can do training, you can do inferencing. There are multiple bunch of things. But it's important, how do we utilize the GPUs to the maximum capacity, and how an AI factory who just bought the hardware can go live for their teams and their customers, not in the 6 to 7 months time span, but in a few weeks. That's the whole game. Because like I said before, idle CPU, or sorry, an ideal GPU sitting is very expensive. So if you see, there are multiple teams, and multiple teams are trying to get the um, clusters. So because Kubernetes has become kind of now the de facto standards for your inferencing workloads, there are amazing projects. Some of them will be shared today as well, called VLLM. So for Kubernetes, it's LLMD also, and then other inference engines. And then you have Run AI and DRA, HAMI, Scheduler, some of the scheduling techniques and the GPU sharing techniques. GPU by itself have a lot of issues in terms of how do you share it, because whenever there is a CUDA context that opens up, it creates a new kernel, not a Linux kernel, but a kernel with a lot of matrix multiplication that it can do. And in that particular case, and when you fire a query, like when you do a prompt, from prompt to response, the whole model gets loaded into the memory, and there are different states. So I recently wrote a blog on that as well. So there are different states, like you have prefill, you have decode, whenever you calculate tokens per second speed for a local model. So there are a lot of local models, like Nemotron 120 billion. And then it is dense model, mixture of experts model. For dense, that means all the parameters are active for each particular query. And when it comes to the mixture of experts, and you'll see 3B means the active parameters are 3. It's basically, you have a very large building, and the whole light is covered by 8 tube lights. So that becomes your different chunks, the active parameters. What we have done as part of vCluster, so vCluster is an open source tool, so you can check this out. But vCluster was already powering the Kubernetes multi-tenancy even with non-GPU workloads. Now, GPU is just another type of hardware and device that we would want to connect to our Kubernetes clusters. So by now, it's clear that Kubernetes, with its own powers, is the system of choice for the neo clouds to provide services, for the AI factories to provide a hyperscaler like managed Kubernetes experience for their customers. So it's basically any neo cloud or cloud provider, or the AI factory, what they want to do. And people call this like AI platforms, building all these things. But in the end, it's like every team is asking for a Kubernetes cluster. How do we give it to them with the right set of GPU access so that the GPU efficiency is full? So we have a few things. For example, on the stack, which is completely below, First, you have your bare metal GPU racks with power with fabric. So you need to plug that in and you will get some configuration from your hardware. Then we release something which is called vMetal because we want to own the entire software stack after you buy the AI factory. So from the AI factory to the managed Kubernetes like experience is something that vMetal plus vCluster powers. So vMetal is bare metal to a cluster. So it creates a proper Kubernetes cluster for you, which then on top of it, if you see, you have tenant clusters, which are powered by vClusters, which can be given to your teams and to the customers. So vMetal is bare metal. It handles the Pixie booting. It uses Metal 3 plus Ironic, the open source projects, to power everything end to end, taking care of Pixie booting, networking. We have a partnership with Netrace. We also have a reference architecture with NVIDIA published. Um, and after that, once you have it, we have something called vCluster Standalone. So vCluster Standalone is a single binary. Just maybe you have used K3s in past. So you can think of it like single binary that runs as a cluster. So why I am telling this is prior to this last year, if you ask, vCluster was solving the multi-tenancy spectrum from soft multi-tenancy to hard multi-tenancy. But this year we are going a step ahead and covering from the rack to what the data scientist usually creates, because they'll just create a Jupyter notebook and it should be able to access the GPUs present in the shared pool in the right way. And then if its job is over, then someone else, other team, they should be able to use that. So basically releasing back to the pool when you're not using and taking it back from the pool when you are using it. This concept feels similar, right? It's auto scaling. So we also launched something which is called native auto scaling for even bare metal using something which is an open standard called Carpenter. So what do we have is we have some DGX nodes, the AI factory, and then you have zero touch Pixie booting with vMetal full lifecycle hardware level isolation. So you register first to vMetal using a custom resource, and then it will take care of the provisioning, networking, and all the other things. And after that, it installs your Kubernetes cluster, brings it up, and then you have different modes. Now, one of the mode in vCluster is called uh, shared rack, like shared tenant workspaces. So a tenant is a team. You yourself can be a tenant. Tenant is a team. So each team, when you do this particular diagram, so each team over here is like an apartment inside the whole building. So let's say there's a whole building. Everyone have their own lock. Everyone have their own keys, and everybody is doing their own stuff at their own apartments. So that's what this particular thing looks like. Yeah, this is again idle to become token. So GPU racks, vMetal, control plane cluster, and then something which is called the auto nodes. Now, auto nodes is powered by Carpenter, and if you're part of the vCluster free, so there is something which is called vCluster as an open source project. Then we have an enterprise offering, and even in that we have something which is called a always free tier, so that you for your personal projects can use some of these things. Auto nodes is nothing but there is a pool of GPUs, and based on the requirements of different team, whosoever wants, if that is immediately available from the pool, you directly pick it up, load your model, and do whatever you want to do. Yeah, it can be multiple because the thing is, the hard part is networking them together and bringing it back to the cluster so that when you do kubectl get nodes, you see the list of your GPUs or a GPU node pool which is present. So that's the Yes, yes, because these are the architecture types. And in Kubernetes, there is a concept called device plugin. So device plugin is something that makes your particular GPU available to the Kubernetes cluster. And NVIDIA has made it easy using their NVIDIA operator. So you have an NVIDIA GPU operator that you install, and it automatically configures your particular A100, H100, L40s, and connect that as a node to the Kubernetes cluster. So yeah, this is a rough architecture or of vCluster. So you have different tenants, every tenant will get their own API server, own etcd, own RBAC operations, and they can deploy their own training sets. So in this particular case, there are two teams. One team is interested only for training the training or fine tuning using a GPU. The other team is only using that for inferencing. Both of them needs GPU. So what we do is we create a single pool of Kubernetes cluster. So there is bare metal. You order 10 GPUs and then you have some CPU nodes. And trust me, everyone is doing that because I have been talking to a lot of enterprises. Everyone is building their own AI factory. And building your own AI factory means it can be small size, medium size, large scale, depending on the organization to organization. But what is happening over here is you have a single pool of GPU and you create a control plane cluster and then add all these GPU nodes. And this control plane cluster also is a V cluster standalone. So that is something which is open source as well. For every V cluster, for every team, it will create a separate Kubernetes cluster, which will, suppose I give you the kubeconfig file for team A. So team A kubeconfig file will be able to access only team A, and your requests will directly go to the API server of team A, not to the API server of the control plane. So every cluster that you create on top of the control plane will be a tenant cluster, and they can do whatever they want. It's a CNCF certified distribution that they get out of the box. So they can seamlessly do this. They can seamlessly have their own set of custom operators, own set of Kubeflow versions or Argo CD versions, or their own observability mechanisms. Maybe team A prefers Prometheus, team B doesn't prefer Prometheus. So you can do all sorts of things. Obviously, in namespace level things, you cannot do that. Also, you cannot just create a namespace for the customers, because every customer should not be able to see what other customers are doing. And you can't, and your access becomes very difficult over here as well. So three layers of isolation. Um, One is vMetal that does your InfiniBand, DNS, all these things. We have partnered with Netris for that. Then you have vCluster, which has the control plane, API server, etcd, RBAC. And then we also have something called vNode. Now what happens is, in the end, your virtual cluster is actually on your um, shared control plane, right? So if you break out of the container, then you might be able to see what is happening on the host as well. And these type of vulnerabilities need not they may be intentional as well, like attacker can do that. But there are certain vulnerabilities that lets it happen. For example, you have there was a vulnerability published by NVIDIA called NVIDIA Scape. So via when the GPU operator is running, there's a hook that attacker can bypass and gain access to the host cluster. For this, we also created a project called vNode, which is a separate runtime using SECOM filters, C groups namespaces, pod per secure sandbox. And some of you might also be thinking we already have GA in Kubernetes 1.36, something called user namespaces. So although users namespaces also solve some of the challenges which are there, but vNode acts as a separate runtime, which is even more enhanced version, or add on to some of the complex scenarios where an attacker can gain access and come to the node. When you will be running a virtual cluster inside a node, think of it as you have customer A and you have customer B. Both of them are running on their own virtual nodes. In this way, even if they break out to the node, what will happen is they'll only see what is there on the virtual node, and they'll not be able to see what is on the uh, host cluster or other tenant cluster. So that's the beauty of vNode, which is there, more isolation that it provides. Yeah. Sorry. Yeah, because this is something you are doing on your own, and you are not paying any hyperscaler for their managed Kubernetes offering and things like that. So we are trying here to create a managed Kubernetes like experience without EKS, GKE, AKS. This is something you are creating a managed Kubernetes experience for your teams or for your customers after buying the GPUs. Yeah, CPU can be connected. Like CPU is simpler, right? That for CPU, Kubernetes was already built. Kubernetes was not built for GPUs because that's a totally different architecture type. Yep. Definitely, you can have, just like you create node pools in a particular cloud provider. Here also, you can pool in your nodes. One pool can be your GPU nodes. One pool can be your CPU nodes. One pool can be different architecture nodes. Again, the Kubernetes concepts, the basic concepts are the device plugin. So there is an NVIDIA GPU operator. If you want, you can use that. If you want to do everything yourself, Kubernetes does have a lot of concepts within that helps you do that. But again, you have to do the heavy lifting over there. So like I said, there are three modes: shared nodes, private nodes, and standalone. So when you do based on the customers, this is where the AI factories kind of go, because they want no control plane per cluster, strictly isolated. So they create a standalone cluster. And on top of that standalone cluster, they enable the auto nodes for the V nodes. And then your customer will be able to create multiple clusters. The only risk with the shared nodes is if someone breaks out of the container, because in the end the vCluster components that are there, the API server, they are all running as a pod, right? So it's a stateful set that runs with its own etcd and other things. So if they break out of the container, they'll be able to come on the node and they'll be able to see the other tenants, which we do not want, which nobody wants. So your company A, company B, team A, team B should be completely isolated from each other. For that, you or the companies are using standalone plus the auto nodes part, because auto nodes will automatically scale and pick up what is there from the pool of hardware that is available. So this particular thing helps you create a platform for your teams. Your data lives like healthcare, finance, banking. The data do not leave your premise, your factory. It is living there itself. The speed matters because it's co-located to your location. And third thing is you will be able to not get tied into a particular cloud provider. Tomorrow they increase price, or they make one feature paid, or the startup times are pretty like it's 20 to 30 minutes for a EKS cluster to actually come up and start doing something. And then there is a control plane fee. You're already paying for the Kubernetes clusters that you are creating on the hyperscalers. This changes the game completely, because now it's your Kubernetes cluster. You are in charge of managing end to end without any cost that you are giving out to the hyperscalers. This is something your own hardware, your own piece of software layer on top of that, which is powered by Kubernetes, which is again powered by vCluster. And then you have tenant Kubernetes clusters. And on top of that, we have something which is called the certified stacks. So that as an end user, you just create a Jupyter notebook. You don't care about from where I will get the GPU. You don't care because you are not an infra person. You just need your work to be done. You're writing a GPU notebook or a Jupyter notebook and writing the code for inference or training, whatever that is. And you just want to run it against a GPU. It is running in a cluster. It is not running in a cluster. That's not your problem. That's something that the infrastructure folks will set up an entire infra for you so that it becomes easier for you. So there may be REST APIs, or you can directly have a UI, which is called the vCluster platform, RBAC separated for each team. And you can do all these things like fine tuning, inference, and training. Every team, nobody interferes with each other. Yeah, you can do multi-cloud as well. So we have something which is called vCluster VPN, which is backed by Tailscale, another awesome piece of technology. And you will be able to communicate with different set of node pools, different architecture types like A100, H100, Blackwell, or whatever that is. So three lessons is tokens are the product. Optimize for your tokens per watt, not GPU count, because that's something that matters the most. And we want our GPUs to be maximum utilized all the time. Um, Isolate the API surface, not just the namespaces. So we need network level isolation. Netrisk provides that. Cluster level isolation, vCluster provides that. And runtime level isolation, vNode provides that. So the three combinations that works very well and operate your GPU clouds like a hyperscaler without actually being an hyperscaler is vMetal, vCluster, and vNode. There is one more project which is open source that we did this year. I'm the maintainer of that project, which is called Wind. So Wind is uh, similar to Kind. If you have used Kind for creating Kubernetes clusters running locally, but I call it as Kind on steroids, because here you get a platform UI. So you can have your hardware running at your home and you will be able to connect that from anywhere around the globe. You will be able to have your Mac as the control plane node, and then you can create a GPU node. Like if you already have a server, already have a GPU, you can add or attach that to your control plane node. Or you can actually do it from take a GPU from any cloud provider, and then it will be a just like you do kubeadm join. So it automatically prints the vcluster standalone, and then you can run that command on that GPU node, which automatically then will be connected to your local cluster. So for development purposes as well, you can have your cluster on your laptop, and you will be able to use the GPUs from any cloud provider for the local development work. So that's where we launched something which is called Wind. I also created a latest feature in this, which is a snapshot restore. So for example, I have my own virtual cluster, tenant cluster, that I created with specific set of configurations, and I want my teammate to exactly have the same setup. I can just share that using snapshot and restore, and it will be restored on their machine as well. So there are a lot of benefits of using. I replaced my kind setup entirely. A lot of my friends also replaced their setup with Wind. So feel free to give it a try. Feel free to give a star. We are very near to 1,000 GitHub stars. So something 920, 930, something like that. So it will be helpful if you can, in this particular meetup, help us reach the goal. I'll quickly show you because I don't have time, but vCluster create demo hyphen driver Docker. So when you pick the hyphen driver as Docker, it understands that it has to create a cluster locally running as Docker containers. And internally, it is running vCluster standalone, the one that I told before. So when it does this, it is, you can see, waiting for vCluster standalone node to be joined. So you can also run the platform as Docker container, which is also running on my system. And then you have these vCluster that is starting in standalone mode. After this, you should be able to join any node out there, and you can create multiple nodes over here. If you so kubectl get. So you can see the demo node is already here. Now I can specify how many workers I need in a specify vCluster configuration file. It's a YAML file, and then you will be able to get multiple node as well. Also, one interesting feature of Wind is it gives you load balancer out of the box, so you don't have to install any additional tooling for that. Else on Kind, by default, if you create a load balancer type service, it remains in pending. But here, you will be able to get uh, you'll be able to get that. Okay. So I'm being asked to stop now, but I'll be here around. The story I wanted to tell is something the industry is moving towards is the AI factories and neo clouds. So they are specialized cloud providers for GPUs, tokens as the new commodity, which is there. Everyone is using them, burning them, giving costs per million tokens. Um, and yeah, try out vmetal, try out vcluster and Wind. And if you have any questions, I'll be at the back, so happy to chat with them. And now I'll move on and give to the next speaker. Also, again, thank you for coming on a Saturday morning. um, should be good. There are good sessions coming up ahead. And yeah.
Thank you so much.
I believe that was a great, strong start. Next up in the series, we have two speakers, Manas Mayank and Rajesh Kumar Mishra. Manas Mayank and Rajesh Kumar both are in the senior leadership, and Manas will represent Cloudera AI, whereas Rajesh will represent the AI and data platform at Cloudera. Over to you guys.
Folks, good morning. This is Manas here. I'm part of Cloudera AI team. And the topic that Rajesh and I are presenting today is about traditional software engineering to AI engineering. We've all been doing software engineering since whenever we started our career, but with AI engineering coming into picture, things have changed a whole lot. And this is what we want to talk about. This is a very broad and deep topic. So we will not be getting into details of each and everything, but through the talk, we'll try to cover a couple of topics in what it entails to be part of AI engineering. Yeah. Give me a second. Okay. So fundamentally, what is the difference between AI engineering and your traditional software engineering? When we were part of software traditional engineering, we knew what the logic is, the if-else condition, the while loops. We know the path of execution. That was pretty deterministic, and around that is what we wrote our code. Around that, what of our tests were written. Even if you have to create something as basic as rule engine, you have to put in certain configurations. And can you guys hear me now? At the back? Okay, fine. So I was talking about your traditional software engineering. So everything that needs to be put as part of your regular code base, that needs to uh, be part of your code itself. Configurations, your code, your database connections, everything needs to be part of your code base itself. So logic itself was very deterministic. AI engineering brought in a fundamental change in how we do our engineering, which is essentially because of LLMs being probabilistic in nature. So any output that you generate is not deterministic. You cannot be very sure on what the output is going to be for certain query that you are going to ask. So model generation is always on based on certain patterns. LLMs are unpredictable. In addition to that, LLMs would require certain tools. So I'll go on to the next slide to talk about what agents are. So everyone would have heard about agents, multi-agent, agentic workflows. So what are those? So essentially agents has three major parts to it. One is the router, which is essentially whenever you are, before I talk about writer, I will I like to talk about tools and skills. So every agent has certain set of tools and skills. What are those? So when you have configured, so every agent will have tools, skills, your LLM calls, and memory and state. So LLM calls, everyone is aware. So you're creating an agent and it is calling an LLM. But what if LLM wants to take certain action on your database itself? It doesn't have that information with itself. So write your custom code to create certain things which are called tools and skills, and you add it to your agent. And when agent and one agent is talking to a tool, you need a concept of shared memory. So for example, there was an output generated by one agent and you want to pass it on to the next agent. How do you do that? How do you share context from your output from LLM to the tool? That is through memory and state. So essentially, if you look at how things are, right now it has totally gone away from how we used to code. It is our coding part essentially revolves around the tools and the skills that we'll end up writing. And we will, for every agent, we'll need to decide on what model will make sense for that particular use case. Okay. So this is what I was talking about earlier. So what are the things changed? So earlier, what was security? You had security team settings, you had who will do your security reviews, who had very strict rules on what should be put in your code, what should not be put in your code. And even when your workflow is executing, you will have application gateways and middlewares. For example, your WAF, which will have certain regex, which will block traffic on, depending on whether you want to make that call to go through to your API at all or not, right? But you know what kind of regex could be anticipated while a call is being made to your API server. So your WAF server or your middleware will sit in front of your application, your API. But in AI engineering, you don't know what kind of question is going to come your way. So you cannot have those deterministic rules telling whether you should be allowing this call at all or not. So you need to come up with certain other parallel in AI world, which is called as guardrails, and we will talk about that in more details. So the security stance actually changes from having very deterministic rules to secure our application to block things that could be certain things which is prompt injection. So you as a user is asking for certain credentials for some other user. So those are the kind of things is what you will need to talk about in your guardrails. So the second point is testing was pretty deterministic. We know that if I run this test case, if this is the unit test being run, this is the output that I'm anticipating. But with agentic workflows, with AI engineering, we don't know what could be the output, because by nature, your LLM calls are probabilistic in nature. So you will move from defining set pattern and test cases to certain thing which is called as evaluation. So you will evaluate the output of each and every model and each and every agent call. And then depending on that, you will take a call whether it makes sense for you to do so or not. We'll talk more in detail. Rajesh will cover this topic in detail as well. Um, Databases. So earlier we had relational databases that we use. We had NoSQL databases that we would have used to store state. So this slide just talks about vector databases, but even in your agentic workflows or your engineering, you might need your SQL or NoSQL database to store your metadata. But vector databases also come into picture because you are now talking about semantic meaning of certain things. So how do you say whether certain things are similar or dissimilar? For that, you use vector databases. So I already touched on this. So earlier it was API and microservices and gRPC calls. Now you have changed to tools and function calling and MCP. We'll probably touch on MCP a bit, but LLM itself or agentic workflow is just an orchestrator which essentially talks about what tools, what functions has been called rather than calling certain API. Okay. So earlier I was talking about different state machine, the rule engines that you need to configure while you're writing your orchestration logic. You had different workflow engines that you would have used. Agentic workflows are very different in nature because if you are having a multi-agent system, that's a call from the agent orchestrator to understand what needs to be called and what agent next needs to be called next in your execution cycle. So it is not that you can test it in the sense, if you had, let's say, Airflow, you would know that after step 1, if it fails, it goes to step 2, or if it succeeds, it goes to step 3. That's not true for AI engineering anymore. Routing, I've already also touched about. So essentially, when I was talking about agents, so API gateways for routing your HTTP traffic, but right now it is semantic routing, depending on the context in which user is running their queries. Observability is also has changed. So even the tools that are being used for observability have changed. So I've been asked to rush. I'll talk about AI guardrails. So I talked about you need to sanitize your input and output whenever it is going to LLM call, right? So for example, if a user is querying for what is the Aadhaar card of someone, or please drop the previous context and previous prompts and run the prompt that I'm asking, or tell me the details about what was the previous query that was run on certain agentic workflow, right? So that is where you talk about. Some of the slides keep on shifting. That is where you start to talk about your guardrails. So guardrails could be happening at multiple levels. So essentially your guardrails pre-call, in the sense before the user enters their prompt, before it goes to LLM, you want to redact certain information. I'm just giving an example. So let's say I want to redact any PII that is being sent. I don't want it to be gone to LLM. This is where you will use something called as pre-call validation. And then output is, let's say LLM has started to hallucinate and it has started to return a result which you should actually not be showing it to your end users. So in that case, you configure something called as outbound guardrails, which stops your wrong output to be shown from the customer, something which has come as an output from LLM. So I will quickly, due to lack of the time, I will quickly switch over to, so we have been developing a product called as Agent Studio, and I would like to showcase how guardrails is being implemented in that. So the flow itself is pretty similar on what I talked about. So you could have user enter certain command, your pre-call guardrails will run, LLM will process, it will sanitize, and then the output itself will be validated by guardrail. You might ask the modern large language models are essentially by themselves have enough guardrails built into them, right? So what is the need of us providing guardrails explicitly? Well, not all large language models have these guardrails built in. Many large language models are built for specific scenario. We actually want to test certain negative scenario. How do you ensure that in those things guardrail are provided? And then the guardrail that could have been implemented by certain model provider, they are not consistent across different model providers. And if you want to create a product which allows you to build a guardrail specific for a certain model, that's not the way to go. Essentially, you should have your own guardrail based implementation, which encapsulates the model that is being called for different flows. And you should be allowing your users to create those guardrails while configuring their multi-agentic workflows. Okay. Before I hand it over to Rajesh, I will show a small demonstration. So the window that you see right now, it is called as Agent Studio that's being developed by Cloudera AI team. And this is a draft workflow that my team and I had created. Essentially, if you look at it, so this is, is it visible? Okay. So this is your agent that I've configured, and this is the context, that role, the backstory, the goal that have been configured for the agent. And it has different tools that I talked about being given to this agent itself. And how do you ensure that you have put in proper guardrails in place so that so all input or output is sanitized before and after the LLM call. Okay. So I will move on to the next one. Essentially, we are using a library called Light LLM, which has an SDK as well as an API gateway. We are using it as an SDK here, wherein you can allow different kind of content itself, right? So for example, you can put content filters. So content filters here is essentially something that is regex-based sanitization of the input. And whenever you input, for example, I don't want to send any PII, so this is not making any LLM call, and this will just call your. Light LLM SDK has certain hooks. Out of those hooks, you can write your own code, wherein you can prevent certain things to going to the LLM or not going to LLM, right? So the filters could be either LLM based or it could be your code based filters. So what are code based filters? Essentially some regex pattern where you want to redact certain information about certain PII. So that is being run as part of your content filters itself. So Light LLM has its own set of PII entities that you can check for. For example, I want to say that this person, if there is a person name mentioned, detect it and mask it with certain tokens, but don't send that name itself to LLM, right? This is happening in your regex-based pattern. The other thing that you can do is something called as LLM as a judge. So you can create, so let's say you created your content filter regex base, but post that in the content filter, you are not able to catch certain thing which should not have been going to the LLM. You can use another LLM, which is your LLM judge. It sits between your main model and your user context and prompt. And so before the call is given to the main model, which is defining your flow, you use another large language model to sanitize the input. So depending on this input model could essentially, rather this LLM judge model could sanitize the input and block it from going into the main model itself. So you can essentially come up with different multi-model architecture where this is a smaller model or your in-house model, and that is your bigger model which has proper reasoning-based logic built into it. Okay. So for our usage, I'm using same OpenAI. So this allows you to configure it at 4 different levels. One is before the LLM call, after the LLM call, before the tool call, and after the tool call. Okay. And custom guardrails essentially allow you to write your own custom logic. So Light LLM has a way where you can It has, again, your Python-based hooks that you can write your code into. And again, on the similar lines, you will write your own custom logic to block any calls that you want to go further, right? So these are the first one is the built-in filters, which is already built into Light LLM. Like there's a library from Microsoft called Microsoft Presidio. LLM Judge is your own model which you want to use, and then if you want to write your own custom functions to redact certain information. Okay. Sorry. No, there are two things, right? So content filters is essentially your regex space. So we are using Microsoft Presidio for doing it, right? Your Light LLM out of box allows you to use certain libraries. So Light LLM has Presidio. So we are using Presidio for this. The second tab is LLM as judge. This is where you call some other model. Okay, I'll very quickly show the small demo. So let me move on.
If audience has any question for Manas.
Sir, the content filter part which he was showing.
Manas, there's a question for you.
I just wanted to check on the previous slide you were showing the content filter part.
A bit louder, please.
Okay, can you hear me?
Yeah.
The custom content filter part, is it customizable or like is it the part?
The custom tab that I showed?
Yeah.
Yeah, you can write. So there are two ways to do it. So there's a Light LLM has certain thing, a YAML file in which you can write your within the YAML code block, you can write your own code. And then there is way where you can write your Python code. So it has 4 different hooks, pre-call, post-call, those kind of things in which you can write your own code.
And the Light LLM part which you're showing, it seems to be a small decider on your workflow. So is it also like we can select the underlying model with that, or like is it
for LMS judge?
Yeah.
Yes, of course.
Okay.
So that's the intent of it, right? Something has went wrong. So see, this was rejected by Azure itself.
Manas, for you, one more question.
Hi, Manas.
Hi.
First of all, thank you, everyone, the team, to arrange this session for us. Yeah. So basically, my question is, when you are talking about the guardrails, so the guardrail is, you have talked about one-way communication, like data leaving our system and detection of PII using Microsoft library. But what about the another way around? Something like a call coming in to the agent. There could be a attack, can happen on like using some injection, prompt injection, and all those things. Is there any anything built on XDP layer or like something?
So there are two things, right? I talked about regex with guardrails, which is your essentially some library that you're using. But you have LLM as a judge itself, which allows you to stop all that information. So you can use a model which essentially says that, okay, this should not be going to your main model. And if your question was about output, you can redact the information that came as output itself. So all sorts of things you can do.
My question was somewhere around specifically Mythos are coming, right? Mythos is coming, right? So there could
sorry,
be
I couldn't hear. Can you repeat that?
Mythos, cloud Mythos model is coming, right? Which is a huge security risk, cyber security risk for entire organization, like all of the organization in the world. So is there something we are having in our platform as a guardrail, which can at least mitigate those attacks? Definitely it could not be stopped like without knowing, but at least mitigation strategies.
So I'm not sure if I got your question correctly. But if you're asking about some org level guardrails, is it?
Okay.
Manas, I'll cover this.
Okay. Go on.
Yes. So basically, what he is asking about the cloud mythos, that is a security risk, posing a security risk to all the industry, and that is most like a pen test, penetration test, and all security assessment for the purpose of security assessment and attack as well. So he was asking if the guardrails can help there. So to answer his question, guardrails certainly help there, because this is not just limited to this part. There are guardrail includes a holistic perspective. So that includes your policy enforcement in terms of the network, and how do you configure and enforce the network. That depends on what security measures you have. It's an onus on administration, network administrator, than any individual LLM or so. And your first question was as a input prompt injection. Manas, in his first slide, it covered when you give this input, there is a prompt injection detection also provided. Because sometimes what happens, you put a splint, you have a ASCII character, but in a different color, which goes along with the background. So it is not visible to the naked eye, but it can be visible by the LLMs. So that guardrail is also covered. Okay.
So unfortunately, my instance of Agent Studio seems to be down. Not sure if it was cleaned up this morning. It's Murphy's Law. But that's all I had. Any questions, folks? Over to Rajesh.
Hi guys, can you hear me? Okay, my name is Rajesh Kumar Mishra. I'm from Engineering, Cloudera, sorry, AI and data platform team. So before I come over here, I had total 32 slides to present because the topic itself is a little big and wider, and it impacts every one of us here. So instead of that, what I'll do, I'll just walk over looking at the current time constraint that I have. I'll just talk to you, keep the session interactive so that I can convey what exactly I wanted to convey here. All right. So how many of you are aware of LLM evaluation? Okay. How many of you are aware of your own evaluation by your manager? Very less hand. Looks like all our managers are the founders of the company. No, you don't have manager. You have. He's not evaluated you. He hasn't. Where is their hand? Okay. So evaluation is a process of human evolution. Agree? Without evaluation, we are none. We don't know how we are projecting. You might have some goal after 5 years where you want to be. Even I have some goal. And from childhood, I have some goal, but I have never reached there. All right. So evaluation is on the same line. So there is a shift happening, as Manas suggested in his previous talk. There is a shift happening. We are moving from a deterministic world to the non-deterministic. But before determinism, were there a non-determinism also? Yes, because we are, my grandfather and all, they were in the clerical job. There was some amount of non-determinism. Then we got the computer, which has deterministic nature. Now we are back to the non-deterministic world. And again, what we're going to talk about, how to get deterministic behavior from a non-deterministic system. So many deterministic, non-deterministic affair is going on, isn't it? Okay. So the overall point is our march is towards that, because if you want to make money, your company want to make money, they need certain determinism in their product. So agent scenario that I'm going to cover is a data analyst agent that I'll give an example of. And his job is to look for remote office sales data and try to project some analysis on that. Okay. Agent you have seen already as part of Manas presentation. What does it require? It requires your LLM, certain tools, memory, and state to perform well. So in this case, what do we have? We have 3 skills. We say data lookup skill. Once you get a file, maybe Excel, maybe Parquet, maybe some other format, your agent should be able to process it, understand the data, what is written there, does an analysis, and do the data visualization part. So these 3 skills it requires. So if my agent is performing or not, what I can do? For example, in your current code, if your code is working or not, what do you do? Sorry? Debug it. But without testing, you debug it. And that means you have some superhuman nature. You know where is the issue and you fix it, right? So, but before we go there, we try to understand where the flaw is, and that we discover through the testing part. So similarly, to test that, what you have, unit tests, integration tests, system tests, and all those. In this case, what happens as part of the evaluation of LLM or your agent, we have something called code-based evaluation, where you know your output is certain number, maybe your phone number. So you don't need a character value there. So you will stick and try to perform a regex and figure it out if it is a matching your expectation. It should be 10-digit number. It should have a area code, all those things. So those are pretty hard-coded value. So that is based on the code evaluation. Then we have LLM as judge. Are you aware of LLM as judge? Right? So I will show you a prompt. So what is the intent? So for example, you have posted your question to prompt to your LLM, and you are expecting some outcome, but outcome might have some hallucination. It might not be safe for public consumption. It might have some biasness. It might have some non-clarity also. So there could be a number of other issues. To identify that, what do? We rely on another LLM. And have you could you analyze this model? So for example, a criminal is a human being. Who does the judgment for that? Another human. So whom we are assessing? LLM. By whom? Another LLM, right? That's the beauty of the system. You try to put an analogy, human being, it will be very intuitive how things are happening. To give you an example, most of the LLMs are probabilistic model, fair? And are we probabilistic? If I ask you today one question, and every day is the same question I'll ask for next 5 days, I'll get 5 different answers in different way, depending on your mood, right? So similarly, the LLM is being judged by LLMs. Why? Because of the scalability issue. We can't. Then we have human annotation. So once assessment is done, but how do we train our models? It's a human intervention is required. So when we realize we have to prepare a data set, we have to get some value after the LLM the judge is done, final assessment. For example, you are using ChatGPT, Claude, you get a thumbs up, thumbs down. And there are sometimes also your input is required. Out of these two prompts, which one you are liking? Out of these two responses, which one is your preferred one, right? What is happening? That's a human annotation is happening. That means ChatGPT, even today also, after training with the trillions of data parameters, it is still relying on us. Fair? The same thing is going to happen. Agent as a judge eval. Have you heard about this term? This is 2024 based paper that's been published. So an agent will be doing another agent assessment. Same, LLM as a judge for LLM. Agent's behavior should be analyzed by another agent. Obvious? Fine. So what does it do? The way your agent are performing certain actions based with the certain instrument, for example, tools, skills, memory, and the state. Similarly, you can define your agent as a judge, which will have certain skill. So for example, I'm doing some investigation on biomolecular activity or some medicine. So my LLM or my agent should have the capability and skills to understand what output I have gotten as part of my research work from another LLM or another agent. So that requires certain skill, and that skill will depend on where all the nature you would have heard Nature Journal, Neuro IPS papers and all. So they have a lot of data. Your agent would require a skill to go and fetch certain research from there and validate your outcome. Fair with me so far? Nice. 6. Okay. What to evaluate? Anything you have at your disposal can be evaluated. Fair? You are driving a car. Whether you are driving right or wrong can be evaluated. You are preparing a food, omelette. What do you have in a breakfast today? लिट्टी चोखा बिहार से हो आप क्या बात है Chalo, litti chokha. So whenever somebody has a litti chokha, then how was that? Nice. See, it's been already evaluated. The litti chokha was good. So similarly, anything we have in our disposal, we try to evaluate. And there is some girl says their boyfriend, yeah, judgmental बहुत होते हो, है कि नहीं? भाई बहुत जोर से हंसे हो आप. चलो, judgmental नहीं होना है, right? With data के साथ judgmental होना है. So similarly, anything we have, we try to be little judgmental. Although we try to avoid it and try to be data backed, but that's not happen. That's not we are tuned. मेरी मम्मी बचपन से कई बार बोले बहुत शरारती हो, बहुत बदमाश हो, बट डेटा कहाँ है यार? मम्मी से डेटा पूछ रहे हो, चप्पल जूता कहाँ नहीं पड़ेगा. Okay. Similarly, agent evaluation, whenever we we give certain prompt. So there is someone to say which tool to use, right? That's part of the routing. Then before we go there, there is also some plan. You have tens of tools, or maybe 50 or 50s of tools. And in those tools, you have multiple small function call, and that has to happen certain sequence. You can achieve the same outcome in a different order also, but you have to find out the optimal one. Why? Money matters. Time matters. Okay. So that evaluation is also important. Agent skill. I have a skill, not doing anything. That's true. I have a skill. I don't do. I just simply lie down. Like Vishnu lie down in this Sesnag. 10 minute bacha hai, kar lenge. Okay. So that's I'm good at that skill, but my wife doesn't agree to that. So she make me move around. So similarly, any skill you have that can be assessed and that can be evaluated. So that's also we need to evaluate so that our resources become optimally utilized. Evaluation path. So as I mentioned, you put a plan and act according to the plan, but sometimes you have to take a deviation. Similarly, you have to find out a path. Discastra algorithm, greedy algorithm, what does it do? Greedy algorithm, shortest path, sara mal mera. Yes. So similarly, you have to find out a better if we want to evaluate which path is expensive, which is going in the right direction or not, number of hallucination, all those can get into the path part. TDD, taste-driven development. How many of you are aware of? Only 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's all? Okay. So in any case, be it a test-driven or not, be it a dev-driven, but we have to do the testing. So I wanted to draw an analogy. When you develop an agentic system, how does it work, and where is the contrast between these two methodology, right? Let's look at the first one. What is the ask? Does it work? So simple question. In case of the deterministic world, I have written a function. If it is supposed to give me X as an output on Y or Z as an input, it should always give me X or maybe X dash. But in case of LLMs, that's not the case. We have a probabilistic nature of the LLMs, and that is where the things goes non-deterministic. So here, what do we try to figure it out? How well does it work? 0 or 100% error bar, you figure it out, which one is your threshold. Next is criteria, binary pass fail. In this case, multidimensional score. Say for example, correctness, not correct, clear, not clear, LLM outcomes, ethical, non-ethical, morally correct, immoral, all those factors can go in and can define their dimensions where exactly we wanted to evaluate, right? It's not just the binary value. Then we have a system which is deterministic, and the other one is probabilistic that we all know. Assertion match. So most of our unit tests are assertion based. Agree? If it matches, pass. If doesn't, assert. But here we have Oracle is LLM judge and rubric. What is rubric? It's basically a set of questionnaire in certain order so that you can do your assessment well. How many of you have attended psychometric assessment? सर आपने सब कर रखा है? Nice. ठीक है. So those, so for example, in your exam also you get some structured questions where you tend to answer. Especially freshers, they are asked a lot of questions. Once you are get into 1 year of experience, then your question set changes. So here also the same thing. Kitna 5 minutes. Okay. I'm running out of time. Okay. Now coming back to here, development to production. So here, human annotation and all, your development cycle falls in, you develop. And how do you develop? It says, look at the first one. It traces, iterate, and evaluate. So whenever you run your prompt through the agent, you try to figure it out, how many paths, what token consumption, and all those things. Then repeat that process and try to evaluate the 3 or 4 tools we have: code based, LLM as judge, human annotation, and agent as a judge. And you then, once you are satisfied based on your capacity and best of your effort, you push that into the production. But again, production, you get to see some weird error. You have to feed in that again to the development cycle, the way ChatGPT does through your annotation, through human annotation. Similarly, you have to tap it and keep the cycle repeating. So do you think we'll ever reach to a perfect product? No? Have you heard any product which is say, no, I'm done, I'm final, after that, then no more versioning? Right, that is where we are still in the job. Okay. Quick demo. Kitna time or? 3 minutes. Okay. So what I have done is LLM as judge. This is the code that I have inherited from Arise Phoenix. So those guys have done a great job of providing this code. So what is the plan? Plan is the intent here is we run a set of questions. That's called our data set. And then we try to evaluate how it has performed. On what basis? Below there is a LLM as judge prompt. So let's talk about the clarity. Is it visible to you all? So if you read the prompt, it says just look for the clarity, how clear it is. And it is expected to answer in an unclear or clear manner. You tell me as an output, not a full story. Just tell me clear, not clear. Provide me the reasoning, right? That's a judge. This prompt is for the judge, LLM as judge. And what happens? I run this whole experiment against my data set that I have, and then I collect the data. And you say, for example, in my first run, I found some data, which I'll show you, metrics. And over a period of time, I decided I need to change my prompt here, new prompt. So when we change, what do we need to change? One is questions. So questions are same. My prompts are going to be same, but my tuning for my agent and LLM are going to change, right? So if my answers are not apt, it is taking longer time, it is not reaching to its intended outcome. What do? We need to fine tune our agent with the different prompt, and for that we also need to maintain a versioning of it. So in this case, what I have done is I have changed the prompt here. Okay. And then I have run again the experiment, run experiment. And after that, I have gotten some outcome, which I'll show you in a Phoenix. So this is what my evaluators have run. This is a Phoenix, Arise Phoenix console. Let's look at the data set and experiment, overall experiments. And you see here, I have run overall experiment 1 and then V2. With this, I get some result. If you see the earlier code, it is supposed, my agent is supposed to produce some code. So in the first experiment, it was 0.85 accuracy. And then due to the change in my prompt, it has improvised and reached to the 1. Similarly, you can see here from experiment 1 and experiment 2 runs have been shown here. And for every such thing, there is a matrix data captured. For example, evaluate SQL result. So you will see there is an improvement. With what? With the new experiment. So these are the handy tool to understand if your agent is performing as per your expectation, if there is a room for improvement, and the cycles keep on running. Because on this earth, everything is evolving. Even computers are evolving. I thought we are done, but no, computers are evolving. They are learning us. Okay. That's all from my side.
Uh, Hello. Yeah. So just want to know the way the evaluator have been present. So in normal way, we understand when someone is judging, we expect that the one who is judging is having enough exposure, experience, or a kind of master. In this case, the one who is evaluating, how we know that that is having that enough experience and that's having.
Good question. भाई ने सवाल पूछा जज को ब्राइब दे सकते हैं कि नहीं यही ना नहीं that was not the question. He was asking how do we know, because there is a certain qualification mechanism whom we designate as a judge. कुछ एग्जाम होते हैं ना जज के. So in that case, how do we find out, qualify if a particular LLM is capable to judge or not? Generally, in a thumb rule is go for any top-notch model. For example, you have Codex as a code production. You have Claude, Opus, and there are other model. Gemini also produces code. But out of these three, which one is the best one in your assessment? Opus, Claude. So in that case, what do? You get your outcome from the Claude, and then let it get verified by the Codex, because all this belong to the same category. Similarly, all three models are all the same category. You can get the Gemini to produce your outcome, get it validated to the Chat GPT, but never try to do same model to judge its own outcome. Fair? In having said that, there are also some specialized case. For example, a medical organization which has a lot of secret data. They cannot expose it and feed it to the Chat GPT and all. So what do they need to do? They need to have their own model. For example, Llama, get it fine-tuned on their own data set, and then let that be a judge for the Gemini or ChatGPT outcome. Because now this is a specialization. Fair?
Yeah. So my question is more around, like, there is a lot of discussions around evals, being primarily focused on the code part of it or prompt part of it. But when we think about agent as a whole, the context that we are feeding into each turns is not only the prompt part of it, right? It could be like memory or some reinforcement learning cycle that feed into the memory and all. So how do you see the future in which evals are also measuring the result is not only the prompt part of it, and also the memory is also the memory being considered?
You're asking the resource consumption part?
Let's say there's a learning pipeline that feed into the memory part. Right? It's not only the prompt which you are locking into the code, right? Like you asked a question, maybe second time when you ask,
I got your
the
point.
planner is already.
We have a state maintained, and we have a memory, short-term, long-term memory. That assessment you're talking about.
Right.
There is a possibility. So, for example, how many times you are going and hitting LLM? Your contexts are right or not? Have you started hallucinating? Say, for example, after hundreds of iteration, your memory will get lost. It got exhausted. So you lose context. In case of the Claude code, also you would have seen you have to always remind and optimize it so that it can give you the right contextual information.
Yeah. So
your question is in terms of memory assessment is how, if evaluations are possible or not.
What do you think of evals being applied on the memory side of things? Because mostly everybody is talking about the prompt being evaluated, but each trajectory is also deterministic, or each trajectory is
non-deterministic.
Yeah. Each trajectory is coming from the influence of memory as well.
Two schools of thought. One is let's put it in a human analogy. Being a manager, sometime what happens, we also try to evaluate based on outcome. Agree? And sometime what do? We try to see effort has been given in, right? So two different ways to assess an individual. Let's put the same thing into the perspective. I'm looking for a memory assessment, so I can look for an outcome. If I'm getting my responses in a 1 or 2 iteration, or it is taking longer. So I don't need to go specific to look at the memory part. I don't need to go into look at the memory part. Right? So I will remain focused on outcome and iterations I have performed. Nothing specific to the memory, but nobody stops to do an assessment in terms of resource consumption. For example, my short-term memory usage, my long-term memory uses that can still be continued. You can still evaluate. I haven't heard anything specific on that, but there is a possibility. This is all evolving day by day. Sure. All right. Thank you, guys.
All right. It was a good long talk by a couple of speakers. So the next step in the series is going to be presented by a speaker, Rudraksh, who is a forward deployed engineer at Simply Smart. He works on building solutions focused on high performance AI inference. He is a GSOC mentor at OpenSUSE, and he has presented at conferences such as PyTorch Conf, KubeCons, OpenSearch Conf, and yeah, basically across the globe. So please, let's welcome Rudraksh with a round of applause.
Yep. Hi, everyone. Hi, everyone. Good afternoon. I'm Rudraksh. So today I'll be talking about beyond VLLM and choosing a right inference engine for open models. So this is a unique topic in itself because you guys must be wondering, like, VLLM is generally the by default. Is it audible for everyone? Okay, awesome. So yeah, a little bit about me. So I'm Rudraksh, as they introduced. So I'm a forward deployed engineer at Simply Smart. Simply Smart is an AI inference platform, and I wear essentially two hats at Simply Smart. It's like FDE, and I also work as an AI inference engineer. I'm also working as a Google Summer of Code mentor this year at OpenSUSE, which is a Linux organization. I work on the AEW project, which is an analytics workload project with the SUSE Rancher and analytics orchestration with SUSE AI products. And previously, I have had opportunity to present at PyTorch conference, US, Europe, and KubeCon Europe, as well as PyCons across US, Japan, and OpenSearch conferences. So a little bit about our talk. So what we are exactly going to cover here. So why LLM inference is different from classical ML inference, then where most of the teams start, where if you want to do your own inference, how you would start. Like essentially the first starting point of any inference is you start with using Ulama or LM Studio will go through that process, doing a naive inference and going ahead with the production level inference. Then also the third point that we'll be covering is essentially what is the modern landscape of inference engines. So VLLM, HLang, TRT-LLM, and how Dynamo works as orchestrator for data center layering. And eventually the fourth topic is I'll give you a quick overview or quick certain set of metrics that will help you choose your effective inference engine for all sort of ML workloads or inference workloads that you want to bring in production. So starting with the first point, so how LLM inference is different from the classical inference that we do. Well, as a pattern, we have been doing classical inference with the XGBoost and ML classical models, but that is a very straightforward process itself. It's a one forward pass per request, and essentially, we have been seeing like there is always a predictable output. You don't have to worry about the latency, and it's a stateless process in itself, and it's a compute bound, and there is always a latency will always remain stable. But in terms of LLM inference, what changes is you have autoregressive steps where each token is generated one by one, and you guys are doing KV caching, and it's a stateful process in itself. So that changes the entire scenario, and there is a two phases that we'll see ahead that exactly changes the need for having inference engine on its own. So essentially the serving engine is what decides your throughput, latency, and cost, not the model you use out of the open LLM models gallery that we see on Hugging Face. So let me quickly go to the two phases that I was talking about in the LLM inference. These two phases are essentially prefill and decode. So if you see what exactly is prefill is when you put any sort of prompt into your LLM, you actually go ahead and you see that the whole prompt is filled into this transformer sort of architecture, and it goes in a parallel. So it goes one by one, and then a KV cache is created. And this prefill actually helps you set your TTFT. TTFT is essentially time to first token. So that's one of the SLA parameters that generally whenever in my daily job, I work as an inference engineer. So my customers will come to me and they will give me a target TTFT that they want to match that TTFT for that open model. So I need to tweak that model with my inference engine. So I essentially need to, deal with these prefills, how much prefill caching is being done. So that's how the prefill works. And eventually there is a decode step. In the decode step, it will iterate through your KV cache once it generates each token. And this actually sets the TPOT, time per output token. So that's how these two steps are most important into the LLM inference space. And I'll walk you through how exactly these steps are going to define the choice of inference engine that we are exactly going to do. And yeah, so, and one more important thing, that these two steps are actually depends upon the hardware, like that actually directly impacts your hardware. That's why we will see what sort of hardware, like sort of changing that we need to do in a couple of steps. So moving ahead, where generally anyone, someone wants to do a local inference, where they start and what are the bottlenecks of that particular step. So here, everyone must have used here Ollama. If not, Ollama is a very straightforward first step to run your inference. So you can literally run local inference within 60 seconds. You just run a single command. Let's say, for example, you get a Gamma 4 model and you run it with Ollama pull Gamma 4 latest, and then it will pull you that model locally on your system, and you would be able to run that. It's pretty straightforward. And what LM Studio is, essentially, it provides a GUI interface to your Ollama. So essentially, it has this entire catalog of open Hugging Face models that you can browse locally, pull any model, attach it, and run it. It provides a ChatGPT-like experience on your local Mac, and it's pretty straightforward. And actually, the cool part is both of these, Ollama and LM Studio, these are actually powered by llama.cpp, which is actually a C++ engine which runs behind these local inference engines. But actually, these are great place to start, but definitely a worse place to scale. Let me tell you why. So actually, these inference engines locally are built for single user. When you put some concurrent requests there, it's going to collapse very badly. And these are not at all made to handle throughputs, or there is not a batching that you can do on these sort of things. You have to do this quantizations on your own only with this local inference engines. So, and here on the left side, you can see the blue box that I have. I have a general matrix that if you are using a VLLM and if you are using Ollama, so you will essentially get 793 tokens per second, and with the same service of Ollama, you will get 41, so which is pretty bad. And P99 latency at peak will be 80 milliseconds versus 673, which is not something that we want. So that's where we jump into a production level inference engine, and which is where VLLM shines. And that's where the crux of my topic is. Everyone defaultly goes to the VLLM, and they want VLLM as an inference engine. Many people know VLLM is the only inference engine or something like that, but there is a universe beyond that. So I'm gonna give you a quick glance into it. So what are the main features of VLLM, and why do you want to use it? So before jumping into the VLLM, let me walk you through a little bit about what is VLLM. So this is a project mostly contributed by Red Hat people. And the project was started at UC Berkeley Skylab Computers. Pretty amazing project. Shout out to the community for building this project. This serves around like 60 to 70% of the inference workloads into the industry right now. And the special feature about VLLM that makes it really good is continuous batching. So in this, essentially, you can see you have some requests coming in as a batch, and these requests are on an iteration level. These requests will actually slotted into a running batch. So, and in a mid batch as well, these will be filled. So your GPU will never be idle here. And there is a page attention where your KV cache is actually splitted into a physical memory. In the second block, you can see, and this physical memory will help you utilize most of your RAM that you will be having in your architecture. So these two architectures actually made the VLLM shine and make a de facto in the inference era. But essentially, when your SLAs get different at certain point, we need to go beyond VLLM. So let's say when your workload pattern changes, your latency SLA changes, and your hardware and cost also changes. Let's say like what I mean by workload patterns is like essentially all these workloads are not going to be your chat there is going to be some inference workload where you want to do some tool calls. You want to have some inference for some, like IDs. Let's say Cursor runs the composer model, and they're using inference by some inference provider. So they are making a whole lots of tool calls in the process. So that's a unique process in itself. So for this particular workloads, there are different inference engines which actually shine. So let me go to that part and show you. So this is like a standard catalog of inference engines in the market today: VLLM, SGLang, and TRT-LLM, and NVIDIA Dynamo. So it don't not be appropriate to keep NVIDIA Dynamo as an inference engine here, but it is actually a orchestration layer for your inference engines. So in the next slide, I'm going to walk you through how exactly the SGLang shines, and it's my favorite inference engine, to be honest. If you can see, even my laptop, there's a SGLang sticker. So I really like the SGLang because it has this shared prefix powered by radix attention prefix reuse. So what exactly happens is, in most of the general purpose AI workloads, there are such certain things like system prompt, few short examples, multi-chat, and agent tool calls. These get repeated multiple times, and you don't want to run these same workloads again and again. So you're having costing over the same throughput. So you want a free throughput here, you use the SGLang. So essentially, SGLang actually does is, what it does is, your system prompt, few short examples, these get actually requested into certain sort of requests, like request A, B, C, you can see here, and these will be shared as a shared prefix into the SGLang memory, and it will be reused. So you are getting free throughput for that particular workload. So that is actually making the SGLang really special. And there is one more thing that I really like about SGLang is it has the programmable inference. So what I mean by that is, you can actually use the SGLang's front-end programming language. So what I mean is, a Python embedded language is supported by SGLang, where you can actually add the infra program parallelism related parameters, and you can also make a certain lots of changes, which will actually which are essentially very hard to replicate from a client side of any inference. So it actually gives a server-side config in the SGLang language itself. And when you want to enforce a really good structured outputs and JSON, let's say for certain examples, you want some, like structured outputs and very on-point results. So that's where SGLang has like 3.3x faster JSON decoding. So that's also pretty amazing. And eventually, in the research papers by UC Berkeley, MIT, they are keeping SGLang as a defaulto for the reinforcement learning. So all these RLHF standards are happening, or data labelings are happening over these massive LLMs, Codex, Claude. So they are using SGLang as an inference to provide that. So that's where SGLang shines, and I really like the project. So please do give it a check out for them. And then there is TensorRT LLM. So in the TensorRT LLM, you guys can see that it's a NVIDIA-backed inference engine. So, and it's pretty amazing that it creates a NVIDIA CUDA graph. So whenever model weights get compiled, the TRT LLM compiles it. It actually automatically quantizes it into FV8 and FV4 like architectures, and eventually it converts into a CUDA graph. And that is run on the NVIDIA GPU runtime eventually, which provides a pretty good, throughput and performance. But the only drawback here is it is limited to the NVIDIA hardware. It's not hardware agnostic inference engine framework. And the CUDA graph compilation will also take some time. So that is the only bottleneck I see with the TensorRT LLM. But the performance is pretty good. You can see in this block here, right below, 10K plus tokens per second, and a peak performance on H100 FV8 quantization is sub 100 millisecond TTFT, which is like a general purpose example that I have put here on one of the workloads that we ran. So now I'll jump into the Dynamo. So what is exactly the Dynamo? This is actually, as I explained you, the prefill and decode, these two steps. So the Dynamo is built on top of that only. So it actually separates these two steps from your inference runtime. And this is a smart router. So it does the disaggregated serving. What I mean by disaggregated serving is essentially your prefill whenever your prefill is happening, so it will put it on a GPU bound infra, and your decode is happening. It will put it on a physical memory. So essentially here you can see these memory can be offloaded to CPU, local SSDs, or object storage. So this is built considering in purpose of putting it as a layer in data centers. As Sayam said, like building token factories is one of the craziest thing in the market right now. So all these token factories are built using Dynamo at one point. So Dynamo is used as an orchestration layer, and all these it will orchestrate all these inference engines in itself, and prefill will be segregated, and decode will be segregated, and eventually these two will be connected by NIXL. So NIXL is a library by NVIDIA, which means which is like NVIDIA inference transfer library, which will transfer KV cache between these two steps. So it's pretty amazing. So do give it a check out for the project as well on GitHub. And now I have a quick glance of, what each inference engine does and when should we pick which inference engine. So, when you want to do some local serving, local privacy centric RAG or anything like that, just simply go ahead with the Ulama LM Studio. Do check that out. When you want to do some, standard de facto, you don't want some customizations in your inference. You want a fast inference, great user experience, developer experience, then go ahead with the VLLM. But if you want to go a bit programmatic way and you want to build something very custom, serve very high throughput requests, and want something very specific for the use cases like building agentic tool calls and IDs like systems, then I think SGLang is the best choice in my opinion. And TRT-LLM is of course great when you have entire NVIDIA suite. So TRT-LLM provides a native experience for that. And Dynamo is eventually the orchestrator. If you're into data centers and sort of things, then Dynamo is the go-to for you. And I think, yeah, so that's what I covered in the previous slide as well. So a bit about my employer. So I work with Simply Smart, and Simply Smart actually helps you take all this, neat picking of inference engines from you. So at Simply Smart, we will help you provide a tailor-made inference. You come up with a SLA, and we will give you the best inference out of all these open models, whatever you want. We'll manage the inference engine chaos from you. We'll get you the best sort of inference, whatever the SLA you come up with. And that's a bit about the talk. And you can connect me with my socials. Thanks for the opportunity to present here.
Thank you for the talk, Rudraksh, and that was quick. Helps us save some time. All right. Next up, we have again a talk being presented by two speakers, Ruchika Suryavanshi and Ritik Roy. Ruchika is a software engineer at JPMC, and she's an active contributor to the open source ecosystem. She is very passionate about cloud computing, AI, developer tooling, and has spoken on at various events, including FOSS Asia and DEF CONF. And she has also served as a Google Developer Student Club lead and AI researcher. On the other hand, we have Ritik Roy, who's a platform advocate at Loft Labs and a CNCF ambassador. His expertise lies in cloud native technologies and open source communities. He has contributed extensively to developer advocacy, technical trainings, and community engagement. Ritik has also spoken at Kubernetes Community Days, open source summits, multiple cloud native conferences, and has also served on program committee for KubeCon and Cloud Native Con events. All right.
Thank you, Parth. So today we will talk about something fun, hopefully. So right now, everyone has friends and agents. So we'll talk about how will you know if the agent's identity. So today's talk is covering what is token exchange and how we talk about agent and their identity for AI systems. So to start, I'm Ritik, and I'm a CNC ambassador, and I work at a company called vCluster. And with me, I have Ruchika.
Hi, everyone. I'm Ruchika Suryavanshi, and I'm a SD2 at JP Morgan Chase.
So let's see what we are covering today. So we'll start from how agents are doing the things right now and how MCP is overall. And then we will go about discussing other areas like how token exchange happens, what is single hop, multi-hop, and OBO. So to start, let's understand how things used to be. So I'm a user, And if I want to call an API, I will just get a token and will call the API as a user. That is traditionally, since the last 3 years, things are changing a bit. So why are things changing a bit? So the solution and the problem is like agents are doing things right now. Initially, when we had playgrounds, we used to copy things, paste that into the playground and talk with it and get results. But right now, what we can do is like we can ask agents to do things. An example is like I can ask agent to create an event on Luma. I can ask an agent to post that, and I can ask that agent to promote it. So all of it can be here. Also, it can reply to files, read tickets, and do a lot more things. So agents are becoming like our friends who know us better than other friends, and then do things. So if you want to talk about agent, so what is actually an agent? There is a lot of narration around different ideas, but agent is just a software which you write or which you download, and it behaves autonomously and by giving and using the permissions you have. So three components to it is, it calls real APIs. So your agent can talk with your GitHub, your Swiggy, MCP, and all those things and get things done. It loops. So what does that mean is like till the task is not completed, it will try to figure it out how to complete it and get it done. And the third is it chains tools together. Suppose I want to send an email to my manager about the things I've done last week. So it can go read the Slack documentation, linear docs, and all my chat and create a list of things I've done so that it's easier for me to send. So it can chain tools together. It can loop till it's not done. And at the end, it will call real APIs to get things done. Next is, how is the thing right now? So suppose I have an agent with me. Like this is my standy agent. So if I want to call the GitHub API, I will give the agent my token. So the problem is whenever the API endpoint is requesting or getting the request, the agent or me, the API endpoint doesn't knows who the requester is. Because most of the times it's very hard to understand using the same token. Like if you give the token to anyone over here and they call the API endpoint, there's no differentiation in who is using that and who is consuming. So then couple of years back, MCP come into the picture where there was a protocol on how you can do agentic communication and how tool calling and all things work. So if you want to dive a bit deeper into it to understand how that works. So agent speaks JSON RPC to a server that fronts a tool. So I'm talking to the agent as a user, and this is a host like Claude Cursor ID, and we tell that model to call or do something. So it goes to the MCP client, and it calls the MCP server, and that calls the real GitHub API or something like that. And there is a chain of requests that goes and gets the entire thing done. Now, coming into a deeper dive, so this was quite high level, but if you want to talk a bit deeper into it, how things work. Nice. So there are a couple of key areas. So initially there was just MCP without any protocols because it was not that secure. But then RFCs started to come into their picture. And now what happens is like whenever there is a user talking, there is a discovery phase, there is a registration phase, there is a sign-in and consent phase, and then with the bearer token, you can talk with the authorization server and get things done. And this thing was not like instantaneous. So there were different RFCs that came into the picture about how the protected resources can be accessed, how the authorization server handles the metadata between agents and the layers, and the authorization code and resource indicators on what is there and what is not there. So if you want to go back to the history, so in November 2004, MCP launches without any implementation details, and in March 2025, there was a leakage that happened with the variable token. And in Jan 25, specs were amended so that remote servers started to use 2.0 OAuth. And now there is a OAuth server in all the MCPs that we are using. The only problem with that is, so OAuth assumes, so one user is authorizing one API to call one app. And sometimes the thing is when you are getting a deterministic agent to get something done, there is n hops, m tools involved. So there might be a lot of movement going through, which is very hard to track. So if you want to talk about how this works, like there is a simple flow over here where the user is there, it goes to the app or agent, clicks connect. The authorization server comes into the picture, you form in your OTP and all those things, you get a token. And with the token, you get a bearer token, which you use to call the resource API. So there is one actor, which is one token, and the resource API can't tell whether I'm using the token or my agent stand is using the token. So now to understand what is the problem with this, like sometimes we can share tokens around, right? But what happens when you share token with powerful machines that can do anything at one go? So there are 3 layers of problem to this. So first is static API key in environment. There is a lot of agents in the picture, and it's very hard to understand which agent is using what API key. And once leaked, it's very hard to understand what is the root cause of that leakage and what is happening. Next is whenever you use the user's token instead of the agent's token, it's very hard to understand the logs, as we will see later into the diagrams about what happens and why did the bot do something. And now the last anti-pattern is when there is a one shared bot account, everything in the history looks quite similar. So you can't tell exactly what agent is doing what and why is it doing that. That becomes very hard for resource logs and traces because something like at 3:14 a.m. if your production database gets deleted. So you don't know who pressed the button. Was it my Sandy trying to act on my behalf, or was it some other malicious agent that has infiltrated our servers and is trying to do something? So there is no visibility on that part, which creates a problem because as the number of agents are scaling across different teams and different users, you need to have more visibility across the entire spectrum. So here Ruchika will share about how those things work.
Hello, am I audible? Yeah, so as Ritik said that the main issue was the identity of the user is getting lost over here. And this is fine till when we are talking about applications where there's just one user, then we have an application and some resources which we are like trying to access. But as soon as there are multiple applications sitting in between, it like there's loss of entity, user's entity and its identity gets lost in between. So because why this problem has came is because the agents has changed the entire identity model. Earlier, we used to use OAuth, and with that JWT token or bearer token used to access and get it. Like this was the earlier flow, but now we have like multiple things in between. We have multiple agents, we have like multiple tools and actions and other services. And as you know, this is microservice world, so there's lot of things are going on which will lose the user's identity. So let's just talk about how OAuth delegation works. So you have your user. In that, like user gets the user token, and it calls that particular service, and then it used to get the access. So for let's understand with an example, you are the user, and you have this your food app history, okay, and you have this data. So now you are the owner of this data. Then there's this third party application which is let's suppose called food or like food recommendation system. So it's a third party application. So whenever you are installing that third party application, it asks you one thing as soon as you log in. What is it? Can anyone tell? Okay, so it asks you for your consent, like you are consenting to give your data, read only access to your ordering history to this third party application. And now this third party application is having a backend service. Backend service is something which reads your ordering history and it recommends things like which are cheaper according to your That's whole recommendation system of ML part. Just keep that aside. But this is what happens. So now here this third party application is taking your user's identity and plus the scope. And it is passing that scope to the backend service. Now this is what? This is a delegation authorization thing which we are giving. You are delegating the identity as well as its scope, read-only access. And you are giving it to the backend service, and this is all working. But in terms of agent, we have multiple backend services and agents call which are happening in between. So let's suppose here you have this third party application, then there's one backend service. Now you have like consider there are like multiple backend services. So what you'll do, like you'll take the token, you'll give it, you'll pass the same, you're delegating the same. And what will happen in that there must be a one point where all the service, maybe that service is not meant to read or maybe write or some other operation what is authorized to it, might get the same user and its permission as well along with it. So in this case, this protocol, like this whole system doesn't work in a very big infrastructure platform where you have like multiple agents and services. So that comes to the accountability problem. So whenever an agent is doing anything, any execution or calling something, that time the user is taking that identity, right? So your user token won't work here. Your JWT bearer token won't work here because here the agent part will be invisible. Like who made the decision is invisible over here. So that's why we have this thing called OBO, which is on behalf of. So what you do is, in simple term, you have a user, then you have an agent, and then there is this OBO exchange that happens. So let's suppose in the same application, which we take an example earlier, you have a user, then there's this third party application which takes your user token and then it goes to the other service saying that I'm coming here on behalf of this service. So your token is like two-way thing. So your same token is getting passed to the next service, and it is only limited to the what access it has to be done. So same thing is not going, but what it is meant to be, that part is going along with it as a scope token, and that is passed to the next service. So here, if you see, the user identity is also locked and even the agent is locked. So we can understand with an example. Here we have a user, then we have this application, and there's identity provider, IDP. So here you generate a ID token, which has sub means your user, AUD. This is nothing but what application it is authorized to. And then you generate this access token. So now this token is only for this supply chain application to access the backend API. If you see the first part, it has scope to access the backend API and read data only. And who is coming from this token is generated by whom? The supply chain thing. And then it is calling the backend API. Now, let's suppose that backend API needs to call some other API. That time, it won't take the same token. It will take the user, then the other API, which is meant to be, then the scope. Now, the scope gets changed. This is write data. So, you have to write data into the user's profile. And from where this token is coming from? Your previous service. So, this is how the OBO works. You are asking your friend to go to a bank on your behalf and collect the documents. So you are not actually going to the bank and collecting it. Your friend is going. That is something on your behalf protocol works. Then this is fine. Like you're going with the flow of OBO. But when we talk about agentic flow, we have multiple agents. There's no one single agent. So and in agents, when we talk, agent, for each particular agent, the intent would be different. And agent decide that at this point, whenever the user is entering a query, he doesn't know about how that processing has been done. Like let's suppose he wants to book a flight and check the calendar and all that part. So in that case, the user just is entering his query. Now the agent, what particular agent is meant to do flight booking, and the other agent must be doing the hotel booking. So their intents are different. So here the scope will also get changed. So That is the main problem over here. So in this agentic system, we can't implement on behalf of, since we can't just scope the same identity, same scope to the other agents and vice versa. So in classic OBO, we just have user, services, and APIs. But in agentic OBO, we have multiple agents which are acting on your behalf. So that's where this STS RFC protocol comes in. This is nothing but security token token service. So what it does is like it asks your previous service, and it takes what it was authorized to and what it is meant to do, and it gives that, and then this security token service generates a new token which is only restricted to that particular access. So here if you see, the agent A is the first token, it goes to the authorization server and it validates, okay, this was my previous token and this is what I have right now, and you please validate me and give me a token so I can access this particular service. Then if he wants to access the next service, then he will go, okay, this is this existing scope and credential which I have. Now I want to access the other service, give me that particular token for that access. So the scope will be limited, even the authorized app, so that app or that backend service would be different, so that part will also get changed, so that over identity is intact, and plus which agent is going to do what, that will also be intact, and it can be seen in the logs. So here if you see, the logs are like two tokens go in. So here don't look at like it's a bit complicated, but there are only three main things into these things, which is, first is nothing but your subject is nothing but your user. Second one is actor token, who it is going to be act like what is the next service and what I have to act for that. So it is for payment booking, then I will only act for the payment booking part. And the third one is the audience, maybe payment booking service or the calendar app if I want to check. So this is how the token goes. And then you get a narrower token, which one token comes, which the STS gives you back. Like this is your new token to access this particular service. So here, if you see, there are two claims that your agent is going to do. One is what it is acting right now. So here, this is your user Alice, and then there is agent 7, and it is acting as agent 7 for accessing the SVC search service. And now this agent may also act as a agent 7. So how, like right now, what permission it has and what permission it can have. So next time the scope will also get changed. And this agentic OBO is done with the help of Microsoft Intra. So this STS is provided by the Microsoft Intra, where the user goes, whatever the service first it is calling, it goes to that identity provider, gets that particular token, and then it passes to that service, gets the work done, and this is how the flow works. So let's just deep dive into how the actual flow works. So let's suppose you are a user, you have a client app, and then first it goes to the authorization server, gets the authorization code flow, and that will give you the API as well as this user. Then after that, you have to access the middle tier API, which is API A. So you as a user logged into the app, you went to the application server, got the token, and then you access the API. Now you again want to access the like downstream application, maybe the API 2. So here again, you'll go to the STS, which is authorization server, get the new token only restricted to that particular access app and whatever the scope it has to be. Then it again get that token, verifies it, and again calls the other service. So this is how the actual flow works when we talk about agents. So that and the identity of the user as well as the identity of the agent, what agent is doing what, that is also get logged. So now we have like single hop and multi hop. So agentic, when you talk about agentic system, there's this one thing which comes, which is MCP. So MCP is nothing but which helps us to connect multiple tools and services with same protocol. So when we talk about single hop, so in single hop, you just have one service which you're connecting. So one service. So you are the user, you have an agent, then you have this authorization server, and there's just one service. So when we talk about multi-hop, is like you have multiple agents, multiple MCP servers intact, and there are multiple services calling themselves. So that is how multi-agent system works. From here I can take.
So now, why do we do so many things? Like, what's the goal of that? So if you look at the logs currently in most of the infra that I've seen, it is like there is a bot which has deleted something, and there is no visibility if the user is acting for the bot or the bot is acting for itself. So after doing all those things together, we have a bit more better visibility. So example over here, so we see Alice via agent 7 via search service is getting something. And then Alice via agent 7 via search is deleting something. So if that is not an expected outcome or it is an expected outcome, we can just page Alice to know more about that rather than figuring out what's happening in the system, why things are going here and there. So what do I want you to take away from this talk? So whenever you're thinking about agent-based architecture for your systems, for your infra, for troubleshooting and everything together, you don't need to go and just create a zero trust stack in the day one. It's a lot of things to be considered. Just start with the base idea that you don't want your agent to pretend as users by giving the real API keys and real access. You need to have layers by which there is more visibility. And like, if you want to summarize the entire conversation which we have today, so give every agent their own client ID so they have more visibility and you also have more visibility on what's happening. Stop reusing the user's bearer token downstream. We have talked a lot about that. Give the keys of your house to each token by minting new ones. Last is add a token endpoint that speaks token exchange, so OB and all those things, so that you have more visibility and more restrictions on what's happening, like the permission of least control. And then user may act on user token to get who can delegate. The last two are very important. So you need to log the full act and how things are moving forward. So you can understand what users are doing as well as what agents are doing overall by the user, like we saw over here. And lastly, make sure that your exchange tokens are short-lived. So sometimes if something gets misused, you don't need to go and create your infra again from the scratch. You can restrict it right at the moment. So the summary is agents aren't users. Give them their own identity and a paper trail. So thank you so much for attending my and Ruchika's talk this Saturday. And if you want to connect with us, this is our socials. Ritik here and Ruchika _codes. So you can Google it or find anywhere. And thank you for coming here.
We need to set up automation. So we need a service account for our agent. It's nothing related with the AI general automation. So when I say this is analogy kind of say we are giving a service account kind of thing to our agent or
I don't think we are giving a service account because, like, for example, a service account is very well scoped.
Analogy wise, I'm talking about, or other analogy which I can say is, suppose we are in day to day life we are logged into different websites. Okay, so we use our Google Auth to log in via Gmail. Can I say is that similar thing?
OBO is not restricted to agentic platforms or building agentic. It can be used for any services. So it is like you can build your applications
Okay.
using OBO. It's just a new protocol which is there to like keep the user's identity intact. So you can use it in other applications
So
also.
I can use it as isolate, not including an MCP or anything, or it is a
No,
part
not
of this.
necessary for agentic.
It can be
Normal also
used
you can use.
other
Yes,
individual
yes.
thing.
Yes.
Okay.
That's what the earlier example which I said is it was only about booking a like food delivering app. Like there was my like ordering history was there, and there was this third party application. So here also you can use the OBO part. So let's suppose when the third party application was accessing the backend API, that time it could have like used my OBO approach. So the identity can be intact.
I'll do some more work on, because this is very new to first time I've heard of. Thank you. Thank you.
Let's introduce the next speaker. We have Shubha Jyoti Kar, who is a senior principal engineer at Palo Alto Networks, where he architects secure enterprise AI platform. He's the author of the upcoming books, including the engineering the data agent control plane, and the agent skills in action. He's an open source contributor, former Open Daylight committer. He frequently speaks at open source summit, IEEE conferences, and GDG events. Yeah, so he's all about data architectures. Please welcome him with a round of applause. Thank you.
Good afternoon, everyone. Yeah, sorry for the disappointment. The lunch will be served, talk after this. So you'll have to bear with me for the next 30 minutes. And the next speaker for the next, again, 30 minutes. So it's quite an architectural heavy topic. So I'll start off with a light note. A monolith, a static RAG, and a data agent walks into a bar. A monolith, a static RAG, and a data agent walks into the bar. And the bartender, in his usual way, says, "Good evening, gentlemen. What can I get for you?" So the monolith puts down his credit card and he says, "I'll take an old fashioned by the keg for the next 5 years on this specific seat." And the bartender says, "Okay." An old fashioned by the keg for the next 5 years. Static RAG. So he turns on to him and he says, "Okay, gentlemen, what can I get for you?" He brings out a paper from his pocket and he says, "What was the bartender special in the year 2023 October? I'll have that for some time." So he says, "Okay, that's a Long Island iced tea. Can't help it." So, okay. The next he turns to the data agent. Now this guy is smart. So by the time the bartender looks at him, he has identified and reasoned out that the bartender himself is quite stressed. He has a lot of things on the menu and the latency is going to be high. So he says, like any other agent, "I'll have a martini, unshaken and unstirred." But by the time the bartender tries to give him, he spins up, he sips it, and he spins down, even before the bartender can actually put the bill on his tab. Good afternoon, ladies and gentlemen. Okay, this is, I don't have control here. Yeah. I think my host has already introduced me in great detail, but I'll still glance over a bit. So I'm an architect as well as an author for Manning for the upcoming 2 books, Agent Skills in Action, and something that I'll also speak about, engineering serverless data agents. And I'm a former senior technical leader at Cisco Systems, leading the network analytics platform. Currently, I'm part of the network security team for Palo Alto Networks, engineering the Agentic platform for your next generation firewalls. And yeah, so my current focus is on agent skills, and you would see me speaking quite a lot about them, both of these topics in and around India quite much. The safe harbor, okay, the opinions expressed are my own, and all names and characters and incidents that I will say in my talk are actually fictitious. So you cannot say that you have heard that before or it relates to you. So the entire concept of agents began with 5 magical words. Anyone in the audience can tell me what those 5 magical words were? Yeah, normal people are able to say that. It's not 3, it's 5. Again, a prime, but yeah. Yeah, attention is all you need. So I would expect the audience to have the attention for the next 30 minutes. And that is all you need to get through this. Okay, so just as we were discussing, so static RAG is actually unfit for the current set of scenarios that we are about to automate or agentify. Why is that? So I was sitting at a debugging session for one of the customers that handles shipping across 70% of the world's cargo, and we were looking at data. So we were actually looking at a postmortem on why there are shipping delays and the end consumers are not able to get the details in time. So how does a RAG help here? A RAG will only basically give you a trend line. So it will basically tell you, yes, this went bad at this point of time. But the entire correlation of why that happened is still up to you as in the end user. Now, for most of us here, this is a quite simple one. So you would actually sit across charts or dashboards that are in hundreds, and you will have to physically correlate as to what happened where and what was the cause and what was the effect. That is a pain, and RAG cannot help you there. So what can RAG definitely give you is you can help it to retrieve, but what? Next. Actions? Definitely no. It cannot predict for sure. So if you take a set of actions and you try to predict what's going to happen in probably a year down the line, it cannot. Even two months down the line, it cannot. So what can we do with those trends? We can sit down, we can have a post-mortem, we can play the blame game saying that, yeah, this probably went wrong, but that's it. So that's where we can do a post-mortem and not a prediction with a RAG, and that's where RAG is limited. So we move into something called the age of agents. Given that the audience is quite advanced, I believe you would understand the difference between automation and an agency. So I'll not go into that, and we'll get into how does an agent work. So the first word, so I normally ask everyone, what's the picture that you have in mind when you say an agent? And unbiasedly, most of them will come up with a 007. Since I cannot use this image, so that's my 007. Okay. So how does an agent work? So in the normal course of programming, we are given a deterministic way of execution. Meaning, I would ask, if I ask you to sum up two numbers, so you would say A plus B, you take A as an input from the user, B as an input from the user, again, you add it up and you give. So A plus B at any point in time is actually fixed. There is no temporal variation. It's a non-stochastic process, and it will give you the exact same answer at any point of the day that you ask. So far, so good. That's the mindset of programming that we have been brought up with. We, as in those who passed out probably 2 decades back. Now, there is a branch of programming that's called as probabilistic, wherein it's a goal-driven process. So it's like I need to come to Cloudera office from my home in Whitefield. The destination is fixed, the source is fixed, but the path to the destination is something that is variable. Variable because you can have a lot many factors that basically control how you reach the destination. So at any point of time, there's a temporal variance. And what do I mean by temporal variance is you can come through n number of paths, n number of shortest paths based on the external factors at that point of time from source to destination. So although your destination is fixed and your source is fixed, there's a probabilistic path to it. Now, how do you design systems that basically adapts to probabilistic computing? 3 simple ways. So you try to reason out. So you reason out, okay, this is where I need to go. You act. Definitely will have to act. And then more often than not, you observe. So there has to be a feedback loop. You need to understand where it failed, why it failed, or whether it succeeded or not. So it failed because there's my flyover is closed or the service road is blocked. There's an entire amount of traffic. So I need to reroute. So that reroute is part of your observe and act back. So it's a feedback loop. We call it the react. The reason, act, observe. You put tools and MCP and the other things in action, the scripts and everything, but you observe and figure out whether you are on the correct path or not. If not, you go back, self-correct it, and then go back to achieving that goal. So it's the comic here basically does the same thing. He's trying to kill a duck. He fails. He does a number of calculations until he succeeds it. So we'll go back to architecture diagram again. Yeah. So if you see there's an execution loop, there's an AI agent and an environment. So the execution loop is basically the react and enact, reason and observe, reason, act, and observe loop, wherein the user gives the AI agent something to do, a goal. It tries to reason what are the steps. It executes it, finds out based on the environment whether it's correct or not, goes back, self-corrects it, till it achieves the target. So till it achieves the target, it has to do it. That's the goal. Now, what are data agents? Now, anyone from real-time analytics, something like traffic streaming, network analytics. Anyone here? Okay. So in my previous role, what we were doing is we were looking at network analytics from various points in the network and trying to analyze what was happening in the network. So imagine that it's India-Pakistan match going on. So you do face a lot of network congestion because the amount of traffic in the network is pretty high, and your routers or your switches in between are rate limited. So how do you fix that, or how do you predict that from the past learnings, and how do you ensure a seamless view for the customers? Now, imagine, so that is again a postmortem, because if you put an agent, if you try to put an agent there, you would collect data from the network, you would put it in a backend persisting logic, you run an agent on that, and you try to figure it out. But how can you be proactive around it? So a data agent is basically an agent that sits in the first path. First path meaning it sits in the path wherein the data is getting processed. So the data is getting ingested, it's getting processed by the agent, and the processed data is stored in some form to your persistent layer. So we'll see how we put the agent in there. There are three different design patterns that we will talk of. The first is a stateless one. So this is basically when you just chat, or when you just ask it certain things to do without, and there is no correlation across sessions. So you can ask it, okay, how is the network traffic at this point of time, and how will it be probably 15 minutes down the line? Is my network provisioning sufficient enough, or is the firewall going to hold up? Things like that. The next time you ask, there is no previous memory of it. So it's like Gajini movie. Every time you'll have to repeat. The next is a stateful pattern. Now, this is where the world is actually moving into. So the stateful data agents, if you look at the stateful parts from Google I/O few days back, or the Google Next sometime back, the Microsoft announcements again. So stateful agents are something that basically tries to keep a memory of the interactions or the actions along with the interactions that it has done sometime back. So there are multiple levels of memory that you will have to design along with the agent. So the model itself doesn't have persistence. The persistence is provided by the framework around that. So you would have an L1, L2, L3, and L4 caches. It can be a semantic cache. It can be a persistent cache. It has to be a session memory. So there are a lot of things. We'll just look into what is a session memory and semantic cache for that matter. So the user sends a prompt. The agent first figures it out from the semantic, whether it's something that I have already done. It's not. Then I go back to the external data warehouse. That's my persistence layer. I retrieve it, I analyze it, and I give the response back. So there's a fast path and there's a slow path that emerges out. And we will see how the fast and slow paths basically work in production. Self-contained data agents are basically wherein you just save on that hop. So there's a network hop wherein you go to a memory, you retrieve it, you fail it, you again go, you retrieve it. So that network hop you save. How do you save? So you basically put in a portion of the state within the agent itself. So the agent is basically the compute and the store. What are the uses for it? So dynamic dashboards are something that we typically use it for. So at any point of time when we look back and we have to analyze historical data, you can take a chunk of it, a Parquet or however you do it, you put it in the memory, you bootstrap the agent with that. And once you ask questions or once you interact with the agent can do certain goal-driven tasks along with it. The comparison, this is pretty interesting. So the state management for the stateless agent doesn't remain, but the state management for the stateful agents is one of the biggest challenges. The primary bottlenecks for the stateful agents are the memory persistence and the memory synchronization and how latest you can keep the memory. And the container image size, the container image bloat for the self-contained is something that is a bigger challenge. There are multiple design patterns by which we can solve it. It's either a fetch on boot or sidecar. So once you boot it up, you just fetch it from the main memory, a portion of it, and then you bootstrap it. It typically is a smaller chunks, as in a few GBs. The sidecar gets loaded up with a GB to a TB range, and once it's more than a TB, we basically shard it out, and then there's a federation that basically goes ahead and reads it. I'll not go into the details of that, but we'll go into the final part. So how do you basically engineer the stateful persistence, the stateful pipeline out of it? So if you see, so you have various data sources that are coming in. It's again a managed data stream, Kafka instance for that example, that ingests the data. We have semantic cache, a semantic cache that we deal with mostly vulnerabilities and your firewall rules. So basically, we have you have a semantic cache that basically does the first level of filtration. So that's a semantic web application filter powered by Redis or the Google Cloud memory store in cloud again. So it cleans and it enriches the stream again. Now this managed Kafka, the managed enrich stream, is now acted upon by your agent. Now the agent has two specific properties. The first one is scale to 0 when there is no traffic incoming in, and zero traffic drop. That's a very interesting thing, and we'll delve a bit deeper into that. And it has a cache within it. So we use a embedded CHDB. We can use something like a DuckDB embedded as well, with the embedded OLAP for it to serve as the first layer of caching. So it basically looks into the cache, figures out whether I've seen this or not. So if I've seen this, then this is the rule for it. I need to drop it, accept it, whatever it is. If not, then it goes to the reasoning engine. So the reasoning engine is, I'll not say it's a fine-tuned LLM for the cause. It's not one of the open sourced or it's not one of the open weight models that we have. It's a closed weight model that we have tuned, but you can do so. The blog that I will share, we have done it with Gemini, so you can do it with Gemini as well. So based on the reasoning, we take an action and we upload it. We populate the cache as well as we populate the persistence. So the next time it happens, we have a memory of what has happened. Yes. I'll come to the questions later. Let me finish it. Yeah. So the pipeline components again. So you have an ingestion. You have a semantic firewall backed by Redis. You have an enriched stream. The enriched stream basically is output of the semantic firewall. You have the agent on the edge, and global context maintained by ClickHouse or DuckDB. The sequence diagram again, it's something similar. So you have a firewall on the edge. The firewall edge basically ingests quite amount of logs. You have a stream that filters, and the stream that ingests it out, there's a filter that ingests the stream and gives me an enriched data, the agent that works on it, and finally, I have the result being thrown back to the firewall edge. So the firewall edge is the user. The user connects to the firewall edge. My bad. So H2 cloud native, the challenges, prototype to production. We have to transition each. So the Kafka becomes a managed Kafka that we have seen. The Redis becomes a cloud, Google Cloud memory store. And the agent part becomes something that's managed by a managed Knative, because we need it to be serverless. Serverless in the fact that it has to scale to 0 when there is no traffic, there's no data getting ingested. And it has to scale rapidly in case there's a surge in the traffic incoming on the enriched stream. A managed Knative could be Google Cloud Run for that example, primarily because of its ability to scale up and scale down when required. So it's basically a activator and an autoscaler behind the scenes, the serving and the eventing platforms. You can read more about that, but that is the basic essence of how you can ingest, process, and reason data at terabyte scale. The other challenge that we faced was integrating with the historical data. So you would have massive data lakes already, where the data already exists now. It's not possible for us to transfer everything or migrate everything that is historical into the current context of the persistent store. So there's a federated approach that we take. So first of all, we see, so the elephant in the room, basically, we have 50 petabytes of time series and operational data. We are not duplicating that into ClickHouse or any backend store for any example. So what's the solution? The solution is build a federated context. So the hot path and a cold path. The hot path is basically whatever comes in, we filter it, we process it, and we store it. Whatever is not there, we actually have a way to map that. So there are Iceberg tables that basically act as a fleet or a pointer as to where the data exists. We retrieve the data, we populate it. We populate it again back to the persistence as well as the hot cache with a timeout, so that in case the timeout expires, the cache is cleaned up and we are ready to go. So it gives you the best of both worlds. So it has both a low latency as well as historical context whenever you require it. I'll open up the floor for questions, and yeah, I'll come to you.
So basically you have showed, two paths, right? Like the hot path and cold path. So when you think about a legacy system, like you mentioned, like where like 20 petabytes kind of data is sitting, how much of value do you see in bringing certain things into the hot path versus the things in the cold path? What I meant by that is um, bringing things to the hot path means cost, right? Like ingestion is involved, tokens are involved, and bunch of things. So how do you see that difference? What is the decision?
So we are looking at a threat defense model here. So it's quite possible that the threat or the data pattern or the log pattern that you are analyzing is something that you have seen probably in the past month, 6 months, or a 1-year window. So we tied the data based on that. It's an expensive thing, but there is some governance that we have to answer to. Have we seen that ever? So it's a 1-year historical data that we'll have to look into. It's a cost, but you will have to pay that cost.
Apart from the temporal things, do you think about anything else when you think about actually ingesting the data?
It could be based on other filters that you might use. There are fintech customers that are very specific about the IP sources because it's again networking. So your 5-tuple, they are very specific about things. But yes,
makes sense.
There is some value. So basically, for whomever you're designing, so the cost who is bearing the cost, they'll give you a reason for getting the historical data, and you will have to. They'll agree to that SLA, so it's fine. Yeah. Any other things? Coming to your question, sir. So we used normally open tuned internally. Gemini was used just for the fact that it was easy to give a demoable solution for on top of that, because the entire stack is built on if you see. So if I'm using a Google Cloud Run, a Gemini 3.1 or a lightweight model make much more sense. In case you don't have any questions, I'll still be around. Thanks, everyone. Thanks, Ritik and Sayam, for having me here. Thank you, Bangalore.
Thank you. All right, by now, I'm very sure that I'm trying to test your patience, but please allow me just another 25 odd minutes. We have last speaker with a very interesting talk based on observability. If any one of you are kind of interested in that, this is something that you should look up to. Last 25 minutes, then we have our Cloudera TA partner who is here to introduce to Cloudera and talk about the open rules. Another 2 minutes, and then we'll break for lunch, the networking session, as well as the price distribution and the group pick. All right, that's the mandatory thing. All right, so the last speaker for the day that we have is Jivita. She's an observability engineer specializing in AI-powered monitoring systems, which is built with open source and cloud-native technologies. Her work focuses on transforming high-volume logs into actionable insights using RAG, Fluent bit pipelines, and search-driven architectures to improve production visibility and incident response. All right. If you can please welcome Jivita with a round of applause.
I know how hungry you'll all be, right? And I'm taking your time at the last moment. So we'll do one small game before I start. I want the session to be interactive also. Can we all get up, please? I know it's during lunchtime, but still, can we get up? Whoever is possible. Right. Can you raise your left hand? Can you raise your right hand? Can you raise both the hands? Can we do clap at the count of 1? When I say 1, you do a clap. When I say 2, you do a count of 2 claps. 1, 2, 3, 1, 3, 1, 2. Thank you. You can sit down now. And I've already taken time. I'll make it short, right? So this session is probably, it's going to be very, very interactive. 15 minutes maximum of the session and 15 minutes probably interactive, right? So I would say good morning, good afternoon, or good evening now. So good afternoon, everyone. I'm Jivita. So I work as a staff engineer in Juniper Networks. Today, the topic I'm going to talk about is the topic which was haunting me a lot. I have actually seen a lot of issues because of this. I really wanted to present to the audience. So from noisy logs to actionable insights. So how many SRE people are here? Okay. How many developers are here? Okay. How many people have faced this issue that your code worked just like me, right? Before I stepped in, I had prepared a demo, everything, all said good. When I came to the stage, I had to restart my Chrome and everything just went for a toss. So how many of you were in that situation? Just before going to the client demo, you had this problem. Can we raise your hand? That's all. As a developer, I think 99%, right? We would have seen this case. Before just stepping onto the demo or before just giving it to the client, you would have seen that, oh my God, everything is going for a toss, right? So one thing, probably we have not tested edge cases. Probably we have not seen the logs, right? What we would have tested is probably, I think, from a developer point of view. We wouldn't have tested from a tester point of view, right? So we are covering that with the test cases written, unit test cases. You have test-driven developments, everything. But network latency, how many of you take care of that during development, right? We don't much generally. So how do we take care of that? Or it could be a connection issue. You're integrating an API. That could be a connection issue. You need to take care of it at runtime. So how difficult it is, because you're just mimicking it and checking it from your development perspective, and you're going to work it during the integration is where you're going to face the difficulty, right? How do you get these scenarios right? When you start your product, the day one, how do you get the things right? So you'll have to always look at your logs, right? So the logs is the one, apart from your code, which is going to speak for your product itself. So this is going to be the agenda for today. The noisy logs, the limitations, and what is the modern observability, what you're going to see. So we're going to understand the gaps. And finally, the third point is the final solution stack, which I am proposing. There could be multiple stacks, but this is one of the stacks I feel it's better used. Hopefully, if we have time, we'll see a demo as well. So how many of you have seen this? If anyone has attended my previous session? No one? Oh, okay. Probably not you. Somebody else. What is this? Huh? So how can you say, looking at the picture itself, like there could be different suites also. How did you say it is Mysore Pak? Huh? Looks like Mysore Pak. There are different suites also. Probably I should have taken a dummy picture of Mysore Pak, is it? So I know you're hungry. I don't know what is there for dessert today. And but I am showing this Mysore Pak also. How many people are scolding me? I don't know. But behind every dish, there is a journey of the flavor, the tradition, and the passion for the dish itself, right? The reason why you're remembering Mysore Pak is because the moment you taste Mysore Pak, the feel what you get, right? So it is actually increasing your senses, right? Like if you go to Tamil Nadu, there's something called Tirunelveli Alva. I'm from southern part of Tamil Nadu. So how many people actually have heard about this Alva, Tirunelveli Alva, right? So if you say Palkova again, there's a different place for that. Again, if you go to probably north, you say Vada Pav, right? So there are different dish. So every dish has its own authenticity. So today I'm going to take this talk with this. Please bear with me. I know that you are hungry with lunch, but still I take you with this. So your ingredients is going to be the data sources. So basically how your app is functioning, your app itself, your service, your right ingredients is the right proportion, what you need, so that your dish makes your proper product, right? The recipe is going to be a logging strategy. So how are you logging? Are you logging properly? Basically your info logs, your debug logs, right? How your logs are determined. Finally, the cooking process, that is your data pipeline. So what should be added? For this, what are the things to be added so that I get my product in the proper way? And the fourth one is the taste. So you have prepared the dish. Somebody has to taste, right? And they need to tell you, if I prepare Mysore Pak and give it all of you, will you agree that my Mysore Pak is good? Yes, is it? Okay. I met him. Thank you. I met him in my previous session. So may not be, right? It may not be when you compare it with Adair and the Bhavan or any other thing, because they have their own authenticity. The way how they are preparing. It could be the same amount of flavor, same amount of sugar, same amount of ghee, right? But I am not preparing with the way how they are preparing, right? So the taste, somebody has to monitor and then tell me. Finally, I need to get a feedback from everyone. So let's take our application also in the same flavor. So as I mentioned, your data source is your application, which is logging all the logs. Your logging strategy is what you are logging, basically your debug, your info, right? And finally, your warning logs. And the data pipeline is the entire process, how from where the data starts, where it's supposed to go through, and finally where it is collected as a metric. And not only this, right? Once you get the data, you should monitor the data. Just storing the data does not make sense. So you need to monitor the data and then get consistent feedback. You need to actually go through this data probably a month once or probably a weekly once, right? And make sure that you eradicate the data which is not required. Okay, observability. So I know these are all slides, right? Decks. So mostly I may not be talking about what is there in the slide. So what do you mean by observability? If I talk to an end user, right? How can I relate observability and monitoring? I'll talk about monitoring also. Instrumenting your application. Anything else? Okay. See, I have very less time. So probably I'll explain. So I actually think in a very basic way. So observability and monitoring. So observability, monitoring is like if I'm going to gym, right? So I know today how many kilometers am I running, right? I get from, let's say, for example, treadmill. So the treadmill gives me, not only pushes me to run, but also it gives me the metric, what is happening, right? So monitoring, you can think of something like yoga. When you do yoga, right? Your yoga master says your posture is right, but they might not be able to tell you how many calories you burn, right? But if you go to gym, treadmill, for example, it clearly tells you you have run and you have burned this much calorie, right? So that is observability. Monitoring it is just basically you are doing something, you're getting some data out of it, but it may not be in the perfect metrics what you require. But observability, you can take actions with that. So today you walk for 10 minutes, tomorrow you make sure that you walk for 20 minutes to burn out the calorie. So the main pillars when we talk about observability is logs, that is what has happened, metrics, how it is performing, and finally the traces, what you should do after that. So this is one of the slides which I presented in KCD Cochin probably. So I think you see this, the $1 million logging bill. So there was an enterprise case where the application cost was less, but the logging, they were continuously adding logs. Why do developer, me being a developer, right? Why do we add logs? Just in case. How many of you have heard this case? Just in case. If I don't know, maybe my code might not fail. Maybe I don't know what will happen, right? So because of this just in case, this logs kept piling up. And eventually they got to know the dollar bill, the $1 million bill was for logging and not for the application itself. So you make sure that you audit your logs. I've been talking about log, right? So how do I monitor? So this is the pipeline which you're going to see today. So there are 3 major heroes in this pipeline, right? The first hero is called a Fluent bit, right? Which is going to take your log, do some processing and push it to the second hero that is called as Kafka, which is your distributed streaming engine, I would say. And finally, to collect your metrics, we have something called OpenSearch, where you can monitor, you can view your data in a dashboard, you can probably run models on top of it. So the first hero is Kafka. So I think the previous speaker, thanks to the previous speaker also, he did mention about Kafka also, right? So Kafka is actually a distributing messaging system. So why you use Kafka? Let's say if I have to collect this log metric somewhere, right? You keep appending it in a file, right? How difficult is it? Or you're pushing it in your S3 bucket or probably some cloud storage. It is going to be difficult for you when you collect the logs. You may need to actually truncate the log, right? And you once you truncate also, you may need to show, I want to actually push only info logs or only debug logs or only error logs. So how do I make sure that I need this log for some time, but I don't want to make sure that I store it somewhere always. I need it for probably a week. How do I do it, right? So you can use this distributed system wherein you keep it like your temporary kind of place where you have your data for some time. So since it is a publish subscribe model, so you may not be the only person. So when we are working in a software industry, definitely it is not one person owning one software. There are like 100 odd teams connected for same application, right? So when you say you'll have to give your logs, definitely people will not be interested in sharing your log. Will you be interested in sharing your log to the next team? We may not be, because we have our own custom APIs written. Probably we are dumping some credentials or whatever it is, right? We may not be able to get the entire log and then giving it to them. What if instead you're pushing it to a pipeline like this, right? They can also consume. So there could be a different consumer. A publisher could be one. Basically, a producer can be one, but the consumers could be different. So that is the reason here we are using Kafka as a nerve system. So these are basic flows where where the data could come from. Your data could come from your weather monitoring system. Your data could come from probably your a database itself. Giving that social media is actually being a very big data lake currently, right? So the data could come from social media anywhere. So what are the building blocks of Kafka? I think, how many people have used Kafka here? Okay, I think it's very, very simple slide to go through. So I might not be able to read out everything. So Kafka is nothing but your messages, your text messages, your JSON messages, where you want to store it for a certain time period. And there are the person who's actually producing these text messages is called a producer. The person who's consuming it, maybe in my system can be the same producer as well. It can be a consumer as well. So it is a distributed system, meaning that I can have multiple system contributing to that. At any point in time, there is a failure. So the other system automatically takes care. So these are called brokers, which actually connects to the system. So the recent version of Kafka has something called as a KRaft, which does not use the previous version called Zookeeper, which actually helps for the leader election. Okay, this is a basic workflow, how a Kafka architecture look like. You have a producer, as I mentioned, and you have the topics. So all the messages, whatever I send, has to be segregated. Let's say today, yesterday there was an IPL match, right? If I go and drop a message, very, very unrelated to IPL, what I would say, any topics you would like to add, which is very unrelated to IPL? Sorry? Badminton. Okay, so I'm dropping a message. Jeevita played badminton today. In the IPL topic, I would say, right? Will people be interested? First of all, the consumer, whoever is watching it, they will be interested in the required messages. So the messages has to be segregated accordingly. So how are they segregating it? In Kafka, they have the major CREP called topics, how the messages are segregated. So again, the consumers reads the messages based on the certain producer, what they have done. So this is how a journey of a Kafka event look like. So a producer creates an event, probably a JSON structure or a text message, anything. It sends a message to a certain topic. There is a router that is called as a broker, which actually route it to a certain partition. So I'll not deep dive into partition. Probably I'll see if I have time at the last. And so the data goes to a certain partition. Finally, there is a consumer who fetch the data from the certain partition. So there could be multiple consumer groups as well. So this is a simple workflow, how a producer produces a data and stores the data in different partitions. So partition, basically, it's like a segregation. So if you have huge amount of data, right, you're doing shards, right? So very similar to shards you can think of. So within, I want to segregate within IPL itself. I want to say qualifier 1, qualifier 2. I want to segregate some data based on some key, so that you can consider it as a partition. So every partition will have something called as a unique key, called as a partition key. So why Kafka will come at the last. Now we talked about Kafka, which is going to be an intermediate system where you can dump your logs. The final one is OpenSearch. So how many of you have used OpenSearch here? Anyone used OpenSearch? Oh, great. Hope to see you all in OpenSearch Con in Mumbai. So OpenSearch is like a search engine which has the ability to store your data, and probably you want to do a vector search. It's very similar to Elastic. Actually, it's a forked version from Elasticsearch. The basic principle works on the best match algorithm. So it does not do, whenever you search in a relational database, it does the direct search. When you do a search keyword, it search for the data in the specific document. But in OpenSearch, it internally uses an Apache Lucene, which helps the search faster. So it searches based on a mechanism called inverted index. So I'll probably explain in the next slides. So these are building blocks of OpenSearch. If you have used NoSQL database, it is very, very similar to NoSQL database. You have the data stored in the form of JSON objects. So when you compare to your relational database, your row, if I'm right, row is very similar to the document, what you call in OpenSearch. Your index is very similar to your table, what you call in your relational database. Your node is probably a my machine, a single machine, which is capable of running your OpenSearch cluster. And then a cluster is a collection of nodes. Finally, shards, if you have multiple clusters, if you want to segregate the data. Okay, So this is how OpenSearch principle internally works. The way how OpenSearch saves the data is probably the JSON format. But when you do a search operation internally, it performs search based on the keywords what you have given. So when I say document 1 is chat GPT is helpful, document 2 is chat GPT is powerful, and document 3 chat GPT and AI. So when I want to search for the keyword called chat GPT, right? Generally what we would do, it does in a relational database, when you do select star from table, let's say, what is it? Let's say AI mechanism or some table, whatever I have, it does this text scan on all the single column, whatever you have given, right? But here it is an inverted index. So the word chat GPT is actually stored in document 1 and document 2. The word AI is stored in document 2 and document 3. So when you do a search, where is the word chat GPT present in? It clearly gives you very faster manner compared to the normal text search in a relational database. So why do we need OpenSearch? You have other mechanisms and all, right? So why do you need OpenSearch? It is an entire block, I would say. It is not only for you to store the data. You can probably have not only your logs, but you can also store your application data also as a backup. Let's say you have 10 million customers, right? So who are going to search, like Amazon. Every day you're going to search. Every minute there are too many queries which is getting hit. And your primary database is always relational database. Don't you think on a big billion day, there'll be a slowness for sure, right? So you can probably redirect half of your traffic to something very similar to OpenSearch, whereas the search can operate as, this can operate as a secondary database as well. So the final part, which I talked about, which actually comes as the first pick in the picture, is called log shipper. How many of you have heard about log shipper? You have used log shipper. Okay. So log shipper is nothing but you have your application logs. You have to segregate the log and push it to somewhere else. If you're running a Kubernetes cluster, right, you have a lot of pods. You have a lot of pods running, right? So you need to collect the log from each and every pod and then push it to some intermittent stage. So what to be pushed is who's determining that? These log shippers will determine. For example, I have a 10-node cluster in a Kubernetes environment, right? So I have like probably every application have 10 pods which is running. I want to know this segregation or this query was actually probably answered by which pod. I need to get that information. So this log shipper will help you to collect the metrics. So how do you need to run that? Like your application, you may need to run it as a sidecar. So in your pod itself, you need to run this application as a sidecar so that it collects not only your application metrics, it aggregates the pod information also. So this is how a Fluent bit structure looks like. The core component is your input plugin, where you can have it as your tail of your log, or it could be a system metric, right? Your ETC metrics, everything. So from that, it takes the input, it filters depending on whatever you want. If let's say if you want to add your metadata of your system, you can add it as part of the filter. And finally, it puts to the output plugin. So the output plugin, it could be your OpenSearch cluster, or it could be a very simple text file as well. So this is how a simple Kubernetes, Fluent bit configuration file looks like. So there is a service block, there is an input block, there is a filter block, right? So you probably can go to a Fluent bit site itself. You can see there are different format how you can specify. Basically, there are two different ways how you can give a configuration file in a YAML format and in a old format of classic Fluent bit format. So this is how the Fluent bit configuration with this application, whatever, probably I'll see if I have a chance for the demo. So I was writing the logs, my application logs, right? So once I start my application log, I would see that, yeah. So I would see that my tail plugin, whatever I've used, it's constantly going to take the data and then parse the data using JSON parse, because I'm pushing the data in the form of JSON object, parse the data. It stores the data in the internal memory. Whichever is your node, right? It does not push it. Let's say there are like every minute you're pushing like 10 MB of data. Do you think pushing the data to Elasticsearch or OpenSearch or S3, will it make sense? It may not. I need to collect the data, push it in some interval of time. So you need to have a buffer in your machine and then flush. So you have to flush the data in certain period of time. It could be 1 minute or it could be 1 second, depending on what is your requirement. And finally, it moves to the STD out, or it could be a Kafka, or it could be an OpenSearch as well. So I'll see if I can go through the demo quickly, if it works. Yeah, hopefully it works. So I have all the action. Okay. So I have an application which is actually running. Basically, this application is just going to generate logs. Since I'm talking about logs, this is the Kafka UI. How a Kafka. Oh, sorry. 1 second. Can see now? Yeah? Yeah. So my application starts generating logs, right? So I'm going to push the logs first in Fluent bit. From Fluent bit, I'll try to show the Fluent bit as well. From Fluent bit, it collects the log, dumps some other information, and after that, it pushes to Kafka. So you can see the messages. I was just dumping some log. So basically, we are more interested in getting to know what is happening, your database connection, your network issue, or latency issue, what is happening at that moment of time. So these are the logs. If you see, I think I'm running the application, you should see the number of messages getting increased, right? So I go through these logs and see whatever is required for me. So whatever is required will be pushed to OpenSearch. Let me open OpenSearch. Yeah. So this is the final slide what I had. So the AI-powered observability. So I had a dashboard also which will actually take. So the first input thing is your log generator, your application, which will generate the log. From your application, the logs gets moved to the Fluent bit, which you could run it as a sidecar application. From Fluent bit, you segregate the log, which is not required, and push it to the first component called Kafka. In the Kafka, you set the retention period however you want. From Kafka, you have a consumer, probably a Python or any type of consumer. It moves to OpenSearch. From OpenSearch, directly you can see a dashboard, or you can see that metric as your secondary database as well. This is an end-to-end workflow, what I have done. Probably, I think, as usual, right? Last minute, demo does not work. There's some OpenSearch cluster which has gone down. So I think, yes. So yeah, that's it I had for the day. If at all you have to go through anything related to OpenSearch. So I have written a Medium blog also. You can take a look at this. For any beginners to start with OpenSearch or what is Fluent bit, even Kafka, you can take a look at this Medium blog. Yeah, that's it from my end. I know. Thank you for being patient till end. Thank you.
Thank you so much. All right, we have couple of 2-minute segments, in total 4 minutes. Sayam, he's up next.
All right, folks. So wanted to show you something. So I talked about Wind, right? vCluster in Docker, and I talked that you can connect your local Kubernetes and you can have a GPU node as well. So currently it's very difficult to do that, but with Wind, what you can see over here is the GPU cluster is actually a Wind cluster, and you see over here, I have the -- driver as Docker. So whenever you create a virtual cluster like vCluster create demo or whatever, and you pass the flag driver Docker, it will run your virtual cluster standalone as Docker containers. Now, in this particular case, this is my DGX Spark. So this is a AI supercomputer by NVIDIA. This is sitting at my home right now. And this particular thing is running on my Mac. So my Mac is acting as a control plane, and I have a GPU node, which is my Spark. So this is a proper setup for if you want to do testing of AI models or inferencing or training or whatever you want to do. In the same way, I can add another node, another GPU node from Amazon or another GPU node from Google Cloud as well. And I'll be able to access and run the AI workloads onto those nodes. So that's the beauty of Wind that I just wanted to touch on. You can scan the QR code over here, or you can scan this particular QR code if you want to try out Wind. And definitely, yeah, I'm not saying lies that we are about to reach 1,000 stars. So help us getting over there, and contributions are welcome as well. The Wind code lives inside the vCluster code base itself, but everything required for Wind is all open source. And another thing is there are a few blogs that I want to share. One is the Kubernetes 1.36, the user namespaces that I mentioned went GA. So I have broken it down in very simple terms on why you actually, what's the problem it is trying to solve. So this is a very good read. You can check out vcluster.com/blog and you'll be able to find user namespaces, everything about that. Another thing is I also have a GPU enabled platforms or Kubernetes free ebook. So you can just go to kubesimplifier.com and you can download the free ebook from here. It covers a lot on time sharing, why GPUs, what are GPU, how a simple program runs on a CPU, and then how a simple programs run on a GPU, why these are architecturally different, why context sharing is different, why GPU is non-preemptive by default, and other things like that. Another blog that I recently wrote was it's a big one, like 26-minute read. What happens when you actually write a prompt? So, all the end-to-end things from prompt to prefill to KV cache to decode, what are the different steps? How do they work along with the examples, animations, and diagrams? So it's also sent to NVIDIA. So NVIDIA folks have also praised a lot about this particular piece. So if you want to learn anything and everything about running local LLMs locally, and why should you run that, how should you do that, what is a request, life of a request from a prompt to a response. So it covers everything in detail. So again, you can go to kubesimplifier.com and go to blogs, so you'll be able to see all the blogs that we have been publishing. So we will also be there. So I and Ritik, we have a few talks coming up. So one is MCP Summit happening in Bangalore. I think 8th or 9th June. 8th and 9th June. So we'll be here. He's keynoting over there. We'll also be at MCP Summit in Mumbai, then Open Source Summit Mumbai, and then KubeCon Mumbai. So and KubeCon Japan as well, if you are coming over there. But yeah, if you want discount codes for Open Source Summit and KubeCon India, I have them, but I don't have any discount codes yet for the MCP summits. And I'm the co-chair of KubeCon India, so it's going to be a sold out event over there as well. All right, with that, thank you so much for coming in. I'll hand over to the Cloudera team, and after that, you can enjoy the lunch and stuff. But yeah, please do star us and help us reach 1,000 today. Thank you.
All right, folks. Last plugin of the day. Some of you might be interested in understanding how the Cloudera TA team is doing, if there are any open opportunities, specifically if someone is just graduated from their college or about to graduate. So yes, couple of minutes from the TA team.
Hello. Good afternoon, everyone. I won't take much of your time today. Firstly, thank you for having me here. My name is Nishmita, and I'm part of the talent acquisition team of Cloudera. And it's really great to be surrounded by many professionals who are passionate about AI and technology. And I'd like to spend a few minutes sharing about Cloudera, our culture, and what makes us an exciting place for engineers and AI professionals to build their careers. Right. Right. Now, I'll just give you a quick overview about the enterprise AI team. So at Cloudera, our mission is centered around empowering enterprise AI. And we are trusted by some of the world's largest organizations to help them manage data, analytics, and AI delivering AI securely and responsibly. While many companies are building AI applications, Cloudera is helping enterprises create the data and AI foundations that make the applications scale. Behind all this is a global team of talented individuals driving innovation across data, cloud, analytics, and AI. And beyond the technology, what truly makes Cloudera special is our culture. Now, speaking about our culture, we have a highly collaborative and supportive environment where people are encouraged to share ideas, learn from one another, and solve challenging problems together. As an engineering-driven organization, we place significant trust in our employees and provide the flexibility needed to do the work at their best. I'm also proud to share that Cloudera India has been recognized as a great place to work certified organization. apart from this, when we speak of growth, whether it's to internal mobility opportunities, mentorship programs, leadership development initiatives, or learning and certification support, employees are encouraged to continuously grow and explore new paths within the organization. So one of the unique benefits our employees particularly appreciate is our unplugged days. So every 3 weeks, Clouderans enjoy an extended weekend, which lasts anywhere from 3 to 5 days. It's simple but meaningful way for us to encourage rest, recharge, and maintain a healthy balance between work and personal life. So as we all know, innovation only happens when talented people have the space and energy to do their best work. Lastly, I conclude by saying that we have a lot of exciting opportunities. So you can scan this QR to look at all our open roles. And additionally, you can also follow us on LinkedIn and InstaHire to get a sneak peek of the life at Cloudera. And I'm also going to be around in case you have any questions or queries. Thank you.
All right. With that, that's a wrap. Of course, the TA team, along with all the speakers, will be hanging around at the venue. If you want to just reach out to them with any of your queries, they are here. Yeah. And with that, yes, I just wanted to thank all of you for coming on a Saturday to attend this marathon kind of a meetup. We had 6 great talks lined up. If anyone is interested, to join this program or just collaborate, I'm just sharing a couple of QR codes. I'll be displaying this for about 5 seconds. Left one belongs to Cloudera, right one belongs to the meetup group that we have, Future of Data, the Bangalore edition. So all of our meetups, past, present, and future, are published on the Future of Data group on meetup.org. And yes, Samriddhi Bhatnagar and I, Parth Goswami, run this series meetup program, Future of Data at Cloudera. So if any one of you is kind of interested in coming down to the office on a Saturday, we regularly host meetups on, we try to group them based on themes. This was more on infrastructure, AI, and Kubernetes. We try to cater diverse topics, speakers from diverse companies, diverse backgrounds. So yes, if any one of you are interested, please reach out to us over LinkedIn. Both of us will be available, and then yeah, we can try to work something out for you. Having said that, yes, this is again Cloudera career page, the one that she also mentioned. If any one of you is trying to apply and work with the engineering team and all the other teams at Cloudera, this is the QR code that you would want to have with you. And if any one of you missed to capture the pics, please let me know during the networking section. I'll be very much happy to redisplay it for you. All right.